All right. Welcome, everyone, to Microsoft JDConf 2025. I'm Bruno Borges. I'm a product manager at Microsoft for the Java engineering group. And if you have been using Java and Microsoft products, you may have heard of Microsoft Field of OpenJDK. That is where I work, but I'm also here helping all of the community in the Java ecosystem to connect with Microsoft engineers, Microsoft product managers, developers inside and outside, and all of the community that really helps build the great tools and services that Microsoft offers to Java developers as well. This is a great year for Java developers who are really engaging with development of intelligent applications, AI, building modern applications, modernizing their Java systems. It's just such a great opportunity to be a Java developer. And if you are watching this, I assume you are a Java developer, and thank you so much for being here with us. Today, we have the Americas time zone with a set of 6 sessions and a keynote with Amanda Silver, Lizzie Reyes, and Josh Long. It's going to be a great keynote. We're going to start the keynote in about 4 minutes. But before we do that, let's just see what we have for today and also for the other time zones, Europe, and then Asia. There is a lot of content, and you won't see the same content on each different time zone. But if you cannot watch a particular time zone, don't worry. All of the recordings will be available on the Microsoft channel on YouTube. All right, so let me walk through a little bit of setup for today. Today we have, first and foremost, the keynote with these amazing people. You're going to hear about Liz talking about LangChain4j. If you're a Java developer and you don't know about LangChain4j, this is becoming a de facto standard for building intelligent apps. But if you're a Spring developer and you don't know about Spring AI, you got to watch what Josh Long has to show as well. Spring is the de facto framework for building web applications in Java. And it's a great synergy between AI, Spring, Java, and Microsoft technologies as well, allowing you, the developer, to build great applications. So the keynote starts again soon, but let's take a quick look at the agenda for JDConf 2025. We got this keynote today, but again, we have great sessions for the APAC time zone and then EMEA time zone, European, Middle East, and Africa. APAC includes Asia Pacific, and other regions. It's a great way to allow every developer around the world to get a little bit of content. And it's also exclusive content that you're going to only see live at these particular times. So for today, for America's time zone, we're going to have, again, Josh Long in the keynote giving a quick summary of what he has to show, but then you're going to jump right in at 9 o'clock with Josh. You're going to have Daniel O from Red Hat showing what technologies you can build with Quarkus and LangChain4j. Quarkus is another great framework for building web applications and REST applications and interfacing with systems and users. Later, we're going to follow up with Adib to show how the Spring AI can allow developers to build intelligent agents, AI agents. After that, we're going to hear from Reza Rahman from Microsoft. What is in the shop for Jakarta EE 11. Moving on with another great developer advocate at Microsoft, Mark Hackler. We're going to hear the best practices for going from development to delivered in production. And almost there, we're going to hear from Yikang Chen from IBM and also Rich from IBM, the advantages of modernizing Java and JVM startup modes with projects like CRaC, InstantOn, and native image, which, if you're familiar with GraalVM, that is the technology that we have. And to wrap up the day, we're gonna hear from Loyan how to test in the era of AI and using AI to power that. So stick around, stay with us. It's gonna be a great show today. For tomorrow, lots of great sessions. Not tomorrow, sorry. For the EMEA time zone, lots of great sessions. Tune in for that as well. So without further ado, and actually before we do that, one last message. If you're if you registered for this, you got points for Microsoft Rewards. And if you checked in on the first few hundred who checked in for this event, you got great, even more points for this event. What can you do with those points? You can exchange for amazing gift cards from Starbucks and games and etc. that the Microsoft Rewards page can show you. So thank you so much for attending JDConf 2025, and let's move on to our technical keynote. So welcoming Amanda Silver.
Hello, everyone. Welcome to the Microsoft Java Developer Conference of 2025. I'm Amanda Silver, CVP for Microsoft's Developer Division, and today I'm excited to talk about everything Microsoft has to offer for Java developers. This is the 5th year of JDConf, and it's incredible to see how far we've come over the years. But one thing has never changed. JDConf is from the community and for the community. This event would not be possible without every one of you joining in from around the world and representing the ever-growing Java community. Java is thriving. It's one of the most powerful and versatile languages out there, driving everything from cloud-native applications to AI-powered solutions. At Microsoft, we are all in on Java, ensuring that you have the best tools and platforms to build, innovate, and scale apps like never before. Microsoft is celebrating our 50th year this year, and from day one, we've been a platform company, making it possible for developers to achieve success. Today, we're going to talk about how you can optimize your developer experience to become more efficient and more joyful, and how we're making it possible to build intelligent applications faster with Azure and AI. And finally, how you can modernize and scale your Java applications on the cloud, ensuring that your apps are future-ready. The Visual Studio family just crossed 50 million monthly active users, and over 3 million Java developers use VS Code every single month. That's pretty incredible. It tells us that Java developers aren't just building great things, you're choosing our tools to do it. And that's a responsibility we take very seriously. GitHub now has 150 million developers worldwide, and Java consistently ranks in the top 3 most used languages in GitHub public repositories over the past year. That means more collaboration, more innovation, and more ways to learn from one another. And here's something that's really exciting. Java is the 3rd most used language with Azure OpenAI. That's a huge sign that Java developers aren't just working on traditional applications. You're pushing the boundaries with AI, and we're making sure that you have first-class support to do it. Generative AI is transforming software development, and at the center of this transformation is GitHub Copilot, fundamentally changing how developers work. At Microsoft, we're committed to leading the AI-powered revolution in software development, helping developers and organizations harness AI to build faster, to collaborate better, and to ship more securely. Developers using GitHub Copilot code 55% faster, enabling them to focus on solving complex problems instead of writing repetitive code. And the impact goes beyond speed. 75% of developers say that Copilot makes their work more fulfilling. 46% of all code on GitHub is now written with AI, and over 20,000 businesses are already leveraging these capabilities to drive innovation. Today, GitHub Copilot is available in the most popular IDEs, including Visual Studio Code and IntelliJ. And just last month, we took another big step forward. GitHub Copilot for Eclipse is now in public preview. GitHub Copilot provides customizable, contextual, AI-powered code assistance that enables intelligent code completions, generates code snippets, and suggests best practices. With GitHub Copilot, you can choose the models that you like best, GPT-4o or Claude 3.5 Sonnet, and more. And it helps you enhance your code quality and makes the development process more efficient and enjoyable. Next, let's welcome Han Wang to show you how GitHub Copilot enables real-time code remediation and completion and reference code on IntelliJ and Eclipse.
Hi, everyone. In this demo, I'm going to showcase some awesome features of GitHub Copilot for both IntelliJ and Eclipse. First, let's talk about the chat experience of IntelliJ. Here, I just selected the scope as the entire project, and ask them for an explanation of the code structure. You can see that GitHub Copilot responded with detailed code explanation in just a few seconds. Now let's move on to the code completion feature. Here you can see that I can even select a different model for this code completion. The code just completes automatically. Now let's move on to Eclipse. Here I'm writing a quicksort function. Similar to Eclipse, you can just trigger the code completion with a simple tab key. Now let's talk with GitHub Copilot. You can reference code within this project and even switch models. As I asked for a comparison of quicksort and bubble sort, GitHub Copilot just quickly responded with a very detailed code analysis. Thanks for watching.
That was awesome. Don't you want to try it? You can get GitHub Copilot for popular IDEs today. Now, we understand that Java developers thrive most when using the tools they're already familiar with. That's why we've built Azure to seamlessly integrate with the development environments that you love. Like we just showed, you can easily create, develop, configure, test, and deploy highly available and scalable Java apps using GitHub and the Azure toolkits for IntelliJ, Eclipse, and Visual Studio Code. Plus, with Maven and Gradle plugins, you can natively build and deploy with Azure services, making the connection between your Java code and the cloud more intuitive. Integrations with Jenkins and Terraform give you the flexibility to automate your Azure deployments and manage infrastructure as code. And whether you're a developer or an operator, Azure meets you where you are, providing the flexibility and the tools that you need to build, deploy, and manage your Java apps with ease. I've already mentioned that the community means everything to Java developers, and our goal is to make sure that you have the best resources and support to thrive as a Java developer. We actively contribute to OpenJDK, making significant performance improvements and enhancing ARM support. And we offer free commercial support for the Microsoft build of OpenJDK for Azure customers. We're also proud to be a strategic member of the Adoptium working group and support popular Java standards and projects such as Jakarta EE, MicroProfile, and more. Our contributions extend to the Spring and LangChain4j communities, where we work together to build deep and robust integrations with the Azure PaaS services. Next, I would love to introduce you to Josh Long and Lise Reyes from the Spring AI and LangChain4j communities to share the latest news. They've partnered with Microsoft to provide frameworks and libraries to integrate with popular AI services for Java developers.
Thanks, Amanda. You know, I'm really excited to be here today because a lot of people tell me all the time, they say, I don't think I have the time to cultivate AI skills. And I'm here to tell you, if you're a Java and Spring developer, you're already uniquely well situated to handle these AI engineering tasks. Because after all, what is AI engineering these days besides the integration with models and the adjacent technologies? So I've gone to the Spring Initializer here. I've stood up a new project using Spring AI, and I'm going to configure a client that's going to talk to the model that I've got auto-configured, and I'm going to use it to ask it to tell me a joke. So let's say chat client dot prompt tell me a joke. I'll get the content back after calling it, and we'll add that to a variable, and I'll just print that out, okay? Et voila. So there's this var, and we'll run that. Now, of course, this is going to need a configuration. It's going to need an API key to do its work, but I've already done that. Before I got on stage, I exported this as an environment variable. And if we look at the console here, we've got, why did this scarecrow win an award? Because he was outstanding in his field. This just goes to show you that it's easy to get up and running and start doing amazing things with Spring AI, which is your one-stop shop for building MCP-ready agentic services and systems today. Now, obviously, we hope that people will try it out at home by visiting start.spring.io. And this is super important as we lead up to the Spring AI 1.0 release in a few months, followed later this year by Spring Framework 7 and Spring Boot 4.0. The Spring team has worked hand in hand with Microsoft to make Microsoft Azure the natural destination for your Spring applications. Thank you for having me.
All right, thank you, Amanda. I'm very happy to be here with you and to present the latest and greatest in LangChain4j. As you probably know, it's a framework to let you connect to large language models, but also other types of models, image models, audio models, much like Spring AI. We have a great integration with Azure OpenAI, thanks to the people at Microsoft who have been contributing amazingly to LangChain4j. We also support things like moderation, which is one of these specialties from Azure OpenAI. But we integrate with many more models and we can easily swap. So Anthropic, Gemini, OpenAI, so many more, but even local models via Olama, even JLama, inference right in Java, and then Hugging Face that offers so many open source models. That's really easy to connect to with LangChain4j. On top of that, we provide a lot of tooling to work on top of the LLMs. And so the first year has been all about building this up from scratch. But the second year now, we're turning 2 almost in May. The second year, we've been more working on production-ready features, such as observability, guardrails, audio, which is just nice for the user experience, but also advanced RAG. So that's like the basic RAG to find pieces of your document that are relevant, but it just works much better. And an evaluation framework. You cannot do without that before going into production. So that comes with Quarkus LangChain4j now. We're very proud to say that our little parrot now wears a tie. He's ready for enterprise environment. And we can also see that in the project that use LangChain4j or that integrate with LangChain4j, such as Apache Camel. The Deutsche Telekom built an advanced coding assistant on top of LangChain4j. MicroProfile integrates with us, Micronaut, Quarkus, and MuleSoft, for example, also uses LangChain4j. So we find that really cool, and we're looking forward to many more years. What do we have to come? Our version 1.0 is so close. It's around the corner, I promise you. We are just making very sure that it's maximally stable and flexible so that we don't have backward compatibility issues later on when we add features. We don't want breaking changes for you developers. So that's coming. We are also adding few shot support. So to give examples to the model, it's a real powerful technique, but it needs some memory tweaking. We are adding caching. We focus a lot on agents and supporting tool calling in all its forms. And then we hope that people will start building on top of LangChain4j workflows, orchestration libraries, so we can build really complex agentic systems, because I think that's where it all is heading at the moment. And what we always did and will keep doing is the new integrations. Whenever something new comes out, we will want to support that for you. And also there, the people at Microsoft, they help us out a lot with staying up to date and with contributing massively, so that for you developers, you always have the cutting edge experience with LangChain4j. And we hope that this partnership with the people at Microsoft will last for a long time. Thank you very much.
At Microsoft, we're proud to remain the only vendor in cloud computing offering a comprehensive suite of tools and services that allow customers to build and operate their applications from code to cloud. This complete offering helps teams across development, app management, and operations move faster and more efficiently. No matter if you're building new or modernizing existing or legacy applications, Microsoft provides you with the Azure AI application platform, fully integrated to support your entire application lifecycle, from development to deployment. It brings together developer services, application services, databases, and AI services, all in one unified platform. Azure's app platform is designed to support any app compute service you need to deploy to and to manage your applications. This includes container services like Azure Container Apps, Azure Kubernetes Service, and PaaS services like Azure App Service, all enabling you to run apps at scale with the flexibility that you need. With Azure's data platform, you can seamlessly manage vast amounts of data while integrating AI capabilities to build smarter and more responsive applications that scale as your needs grow. And Azure's AI platform helps you build and enhance intelligent applications. You can integrate your solutions with Azure OpenAI, Azure AI Search, and build with robust ML ops with AI Foundry to help you to design, customize, and manage the next generation of AI apps and agents at scale. Microsoft Azure is uniquely positioned to help you unleash the power of AI and take your applications to the next level. With our fully managed offerings and end-to-end cloud experiences, you can accelerate your applications, move to the cloud, while using the tools you already know and love. With over 90 compliance certifications, you can trust that your applications are secure and meet industry standards. 95% of the Fortune 500 customers are already trusting and running their mission-critical workloads on Azure, which is a testament to the reliability and scalability of our platform. Microsoft's strong partner ecosystem provides best-in-class solutions to help you modernize and extend Java workloads. With partnerships like VMware for Spring Cloud and Azure, Red Hat for JBoss EAP, IBM for WebSphere solutions, you get joint development and support for seamless migration. Azure also supports fully managed services like MongoDB, Redis Enterprise, and Confluent Cloud for Kafka. Additionally, marketplace images for popular Linux distributions like Red Hat, Ubuntu, and SUSE offer flexibility for your Java applications. This growing ecosystem ensures that you have everything you need to succeed with Java on Azure. Take JBoss EAP on App Service as an example. JBoss EAP on App Service is more cost-effective and seamless than ever. With the free tier, you can get started at no cost. As you scale, memory-optimized SKUs drive even greater efficiency. With a recent 63% reduction in JBoss EAP licensing costs on App Service, there has never been a better moment to make the move. And we're taking this even further. You'll be able to bring your own JBoss EAP license to App Service, unlocking even greater value through direct licensing from Red Hat. So nothing's stopping you. Give it a spin today. Late last year, we announced a private preview of GitHub Copilot's ability to upgrade your Java codebase. Mission-critical tasks like upgrading Java code, runtimes, frameworks, and dependencies can be a challenge and quite time-consuming. With the Upgrade Assistant, you can streamline this process significantly. Start with your local Java project, receive an AI-powered upgrade strategy with humans in the loop at each step, and let Copilot handle the bulk of the work. This powerful tool really helps you modernize your Java applications faster, allowing you to focus on building intelligent applications with confidence. So let's welcome Nick Xu to showcase a demo to walk you through this experience.
I'm a Java developer using VS Code and GitHub Copilot. Let's start the Upgrade Assistant to help me upgrade to start my Java app from Java 8 to Java 21. It uses several AI agents in the upgrade process. It starts with creating a plan and identifying any dependencies like Spring Boot Framework and JUnit. Then the assistant executes several steps in the plan. First, it verifies if the project is in a clean state. Then it uses an open source tool called OpenRewrite and automatically transforms my code to newer versions. Then it uses other AI agents in a dynamic build fix loop to address the issues. During the upgrade process, the assistant also runs unit test cases as part of the validation. At every step, I stay in the control. I can see all summary, test case, and dependency changes, review the commits and diffs, all the logs and outputs. Finally, I can also generate additional unit test cases and see a report of the generated tests. The GitHub Copilot Upgrade Assistant for Java helps me execute the mission-critical tasks, reduce technical debt, and gets me ready to move my app to the cloud.
Now, we're already previewing this with many customers, so sign up to get access to the private preview. Beyond GitHub Copilot, we offer Azure Migrate, an all-in-one solution to simplify app migration, modernization, and optimization on Azure. It provides capabilities from discovery to deployment, gathering relevant details about your applications, infrastructure, and dependencies, giving you deep insights to assess, plan, and execute your move with confidence. Paired with GitHub Copilot, it's never been easier to modernize your code and apps and accelerate cloud adoption. Start your journey with Azure Migrate today and build for the future. Now, we've talked a lot about our services and offerings to help Java developers innovate better and faster. Next, let's take a look at a few customer stories. For 134 years, Manulife has been a trusted partner for millions of customers, helping them make smarter financial choices. As part of their commitment to innovation, they embarked on a cloud journey. migrating applications from on-premises data centers to Azure Kubernetes Service to eliminate the burden of managing infrastructure internally. This move helped Manulife with significant cost savings. Today, Manulife is running 50% more services on AKS than they were on Pivotal Cloud Foundry, all while operating at 65 to 70% of the original cost. Manulife's US business, Asia operations, and corporate functions are now fully deployed on AKS, powering a multi-region, load-balanced environment with 250 plus servers and 3,000 microservices accessible through APIs. Besides AKS, Manulife is taking full advantage of Azure, leveraging over 75 products and services on Azure, including Azure AI, Azure Machine Learning, and Azure Cognitive Services. Manulife uses Azure AI services to help with document analytics to address fraud detection, identify hidden patterns, and proactively mitigate risks. By eliminating data silos and building on a cloud-first foundation, Manulife is accelerating innovation, improving security, and delivering smarter, faster solutions to their customers. Fujitsu chose to modernize its Java applications by migrating them to Microsoft Azure, aiming for improved flexibility, efficiency, and scalability. Initially, they faced challenges in adapting their established Java systems to a cloud environment while maintaining reliable performance. Azure's support for Java apps, specifically through Azure Container Apps, made it possible for Fujitsu to containerize and manage their applications more easily, ensuring a smooth transition. This approach allowed them to keep their Java-based operations consistent and reliable while benefiting from Azure's cloud infrastructure. By deploying Java applications on Azure Container Apps, Fujitsu could scale their services dynamically, only using resources as needed. This setup offered better cost management while enhancing responsiveness and performance for their clients. The ability to use Azure Managed Services for container orchestration meant Fujitsu's team spent less time on infrastructure tasks and more on innovation and customer-centric improvements. Overall, the deployment on Azure allowed Fujitsu to future-proof its Java applications, making them adaptable and sustainable in a rapidly evolving digital landscape. There are so many customers who call Azure as their home for enterprise Java applications. Not only our customers, but Microsoft is also running on Java too. At Microsoft, we've got a massive crew of more than 100,000 developers and IT professionals dedicated to creating cutting-edge solutions every day. We serve as the first users of our own innovations, ensuring that they meet the high standards of our customers and what you've come to expect from us. Given that some of our critical workloads at Microsoft are running on our Java tools and platforms, you can trust that your organization and solutions will feel strongly supported. So thank you all for joining us. Check out the 2 days adventure of Java and AI at JDConf, and take the Java Learnings Challenge to win a badge. Don't miss out on the great sessions from JDConf. We're excited to present over 20 exclusive sessions brought to you by Java experts from across the globe and available to you across all major time zones. The conference covers a massive variety of topics across Java 25, Spring Boot, GitHub Copilot, the AI developer experience, building agentic AI systems, data and AI, and many, many more topics.
All right. I hope you enjoyed the keynote. I certainly did. I learned a lot from Lise, a lot from Josh and Amanda. Our next speaker is actually one of them. I'd like to welcome to the next session, Josh Long from Broadcom. Yeah. Josh, you got to turn on your camera if you want to show up. Or at least you can talk to me, I guess.
Josh is in the studio, but he does need to unmute his mic and turn on his camera.
All right, so we got Josh on the backstage of the live streaming, and we're going to hear from him very soon as soon as he shows up. So one of the things that we have for this conference is this kind of thing that you're seeing now. Between the sessions, you're going to hear the host in this time zone, myself, speaking to great speakers like Josh Long. Welcome, Josh.
Oh, thank you. Sorry about that. Technical difficulties. No, it's more of a coffee difficulty. It's 9 a.m. I haven't had enough. Clearly, that's an exception of some sort. Good to see you,
Yes.
Bruno. How are you, my friend?
I'm good. How are you?
We'll get there. Just need some coffee.
So, tell me a little bit of that amazing background that you have. I assume that is not a Teams virtual background.
Oh yeah, I know. San Francisco. It's a small little city by the bay here in California, and you know, that's the Salesforce Tower in the city and all that stuff. This is my
Awesome.
home. Or,
So, why don't you show us what does it? I mean, one comment I have for you, Josh. It's I know you for many years, and it feels like you have already been vibe coding for many years.
True. I'm all about the vibe coding. Sometimes I code so aimlessly that I never get there, but it's okay. You know, it's all about the vibes. It's fine.
It's all about the vibes.
Yeah.
So how about we go for the vibes now, and you show us what you have.
Sounds good. All right. Thank you. Good morning, everybody. Talk about upgrading code, and particularly upgrading like an application from 8 to 21, I think it was. And I would just urge you to no, don't stop there. Keep going. Go straight to 25 or 24, I guess is the right version today. You know, we live in an amazing time, and you know, every 6 months they give us a brand new release of this amazing Java ecosystem. And I would encourage you to make sure you do whatever you can to jump aboard that particular release train, because it's awesome. There's just so much good stuff. And so, look, I'm really excited to be here. You saw my coordinates, right? My name is Josh Long. I work on the Spring team. I have a YouTube channel. Look, there are things we all have to do that we're not proud of, okay? I am a YouTuber, okay? It's not like I mean, it's just, look, it is what it is, okay? You can find me online. I have the Bird website. Here's the code, that kind of stuff. And I was really thinking about what could I show you all today to kind of better demonstrate all the cool stuff in the Spring ecosystem. I thought we could revisit the old standby favorite, the Spring Pet Clinic. And this stuff is like this is a sample application, but it's 20 years old in some ways, but it's been updated recently. And so I thought, well, we could look at that. And then I got a little bit more ambitious, and I thought, well, we could actually just look at the organization. This is a huge organization with 23 different repositories that demonstrate the Spring Pet Clinic in terms of all these other technologies. And I thought, that's pretty cool. We could look at that, right? And then I thought, well, we've got like 25 minutes. There's just no way we're going to be able to look at all that cool stuff. And so I said, okay, we're going to focus on something in particular, right? We're going to focus on one or two little things today, and see how we can build services and software that better demonstrate sort of the typical approach to building AI sort of services today. And I thought we could do that. But I still like the domain. I like the domain of like dogs and cats and pets. And I mean, come on, right? We all love dogs. We all love cats. Everybody loves a good pet. They all love their pets, right? I mean, everybody loves pets, right? I mean, come on. You probably love your pet. Everybody loves their pet. And I look, my pet is terrible. Okay. I don't know. He's not a good dog. My pet is named Peanut, and Peanut is a terrible dog. But you know, I mean, not a good boy, right? Just a bad dog. But we keep him for 3 reasons. Okay. The first reason is just the bedrock fact that, you know, you know, all animals deserve love, you know, even terrible dogs. So there's that. We keep him in the house because no matter what, he deserves a loving home. And then 2 is that, you know, just ego. Okay. I'm just going to be real with you here. Okay. Just ego. In my home, my partner and my daughter both speak 5 languages. I only speak 3.5. So if we didn't have that stupid dog, then I would be the stupidest in the house, and that will not stand. Okay, so we keep the dog for that reason. And then also, again, you know, just gonna level with you here. He is pretty stinking cute, right? Look at that dog. That's a very cute dog right there. He is very cute, but evil, just pure malice. Okay, malevolence through and through. And so this dog, not a good boy. I mean, this is actually the best way to experience my dog Peanut is through a photograph on a screen over a streaming service from ideally a different continent, right? He can't get you. He can't swim, not that far anyway. So you're safe, you know? He's not a good boy, but he does remind me of of another dog about which I learned during the pandemic, whose name is Prancer. And Prancer's owner tried to find a home for this dog. And so she talked about this dog and she put out an ad trying to rehouse this dog. And this ad is hilarious. It went viral in the pandemic, 2021. And she says, okay, I've tried for the last several months to post this dog for adoption and make him sound palatable. The problem is he's just not. There's not a very big market for neurotic, man-hating, animal-hating, children-hating dogs that look like gremlins. But I have to believe there's someone out there for Prancer because I'm tired, and so is my family. Every day we live in the grips of the demonic Chihuahua hellscape he has created in our home. She continues, I was excited to see him come out of his shell and become a real dog. I'm convinced at this point that he's not a real dog, but more like a vessel for a traumatized Victorian child that now haunts our home. And then she finally continues and warns ominously, Prancer wants to be your only child. And she signs off with some other advice. We already addressed the men and children situation. If you have people over, he would have to be put away like he's a vacuum. I know finding someone who wants a Chucky doll in a dog's body is hard, but I have to try. And then she warns, oh, he's only 2 years old and will probably live to be 21 through pure spite. So take that into account if you're interested. Oh, so this does not sound like, this sounds like this dog might be a little bit of a challenge, right? A little bit of a spicy dog. But, again, very, very cute. Look at that dog. I'd pet that. That's a cute looking dog. So I can kind of see the appeal. And I think about these two dogs, my terrible dog, Peanut, and this terrible dog, Prancer, a lot, right? Like, what if we could build like a service to help adopt these dogs, right? So I think we can go back here to my second favorite place on the internet, start that spring rail. And we're going to build a brand new application using, of course, Java 21, or later, arguably, you should be using nothing but Java 24. This is an amazing release. We have some things we need to specify. What do we want to call the service? I'm going to call this adoptions, okay? And then we have some things we need to add to the application. The GraalVM native image support, the web support, the PG vector support, that's the client support. If you, by the way, want to get started with that kind of stuff and you want like a Docker Compose file, just hit Docker Compose and it'll automatically stand up a Docker file for you. But I've already got a database of dogs up and running. We've got Docker Compose, we've got the web. We need OpenAI or Azure AI, or we need a module to support talking to a different model. I think, what else do we need? We need an ORM. Let's use Spring Data JDBC to get that. And then, of course, we'll build a MCP client and service in a bit here. So let's add MCP client to the mix as well. Okay, so I'm pretty happy with that. And then, of course, finally, we've already got the GraalVM support. So then let's hit enter. And I'm going to open this up in my IDE. It doesn't matter which IDE you use. I like IntelliJ, but Visual Studio Code, as we saw earlier, is an amazing, amazing piece of kit, obviously. And by the way, the Spring team works on the language server that powers the support for Spring in Visual Studio Code. So, you have our endorsement either way, okay? All right, so I've got an application, and what I want to do is I want to build an application that helps people adopt dogs. And so how that works is normally you go to a shelter and you talk to somebody about the potential dogs in the shelter, and then you ask questions, right? So I've got a database here, JDBC, PostgreSQL, localhost, my database, yeah? And then it's Spring Data Source username, my user, and then Spring Data Source password is secret, right? So if I click on that little button there, hit test connection, hit apply, hit OK, okay, and then I go over here, you can kind of see right there, tables, and you got this table called dog, right? And there's our boy Prancer, right? His ID is 45. His name is Prancer. He's described as a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like a gremlin, okay? And of course, very surprisingly, I mean, nobody could have seen this coming. He doesn't have an owner yet. So what we're going to do is, success, with air quotes there, success is that by the end of this, I've got two, not one, but two terrible dogs. So we're gonna, that should be not null if we've done everything correctly. Okay. So, obviously, I want to be able to have a discussion. And so again, we want to use AI to support that process. So I'll build a little controller here. Okay. And we're going to say assistant controller. Yeah. And we're going to need to talk to an AI model. And there's this thing called a chat model in Spring AI. Okay. And the chat model, in turn, we can talk to via the chat client. If you've ever used the web client or the REST client or the JDBC client or whatever, you've probably already dealt with something of the same sort of shape and form, right? And so, I'm a big believer in Spring AI's chat client. It's been written by only the best people, okay? Only the best people. So there's that. And so we're going to actually create an endpoint here to support interviewing, the user or the AI about potential dogs in the inventory. So we'll create an endpoint here, and it'll be a string inquire. And what we're going to do is we're going to inject the old Spring Framework chat client there. Okay, I'll call this AI. Hey, very good. And here I'm going to say this.ai.prompt.user, and then we're going to take in a question from the user, and that'll be a request parameter. So request param string question dot call dot content. So there's a response, yeah. Okay, so there's our simple request response loop. Okay, so let's try it out. Let's see if this works. This only works because we have auto configuration on the class path, which will stand up an OpenAI, or if I had the Azure one, I would use that, or whatever. It would stand up the appropriate model. Now I happen to have an environment variable that looks like that on my machine, so this is still going to work because that environment variable gets normalized down to that configuration property. But just trust me, even though I haven't specified that explicitly, trust that it's been done, okay? And forgive me for not leaking my API credential. Okay, let's see what we've got here. Oh, I've got the Docker file, do I? Oh, we don't want that. I've already got a Docker image running. I accidentally forgot to deselect that checkbox over on the old initializer. And that's okay. You can actually kind of see what you would have gotten had you selected that checkbox. You would have gotten built-in support for generating and then standing up those Docker images each time you start the program. This allows you to get started really quickly. Okay, next thing. Oh, we don't have the Postgres driver on the class path. Oh, that's embarrassing. Look at that. Let's go back here. Okay. No, we want PG vector actually. That's PG vector. Okay. And we're just going to copy and paste all that. Okay. And did I get rid of the Docker Compose stuff? There it is again. Huh? And nice. Okay. Command Shift I. This time with all the marbles. The important bit was that I added the PG vector or Postgres. I don't think you need this if you have that, but whatever. Who cares? Okay. Take 5. Okay. It's up and running. We got a database. We're good. Now let's try our endpoint here. HTTP 8080/jlong/inquire. Okay. And this is going to be a post. So we'll say form post, and then we'll say question equals my name is Josh. Okay. Oh, nice to meet you, Josh. How can I assist you? Great. Let's see. What's my name? Let's see if it knows. Okay. I'm sorry, but I don't have access to personal. Look, it's already forgotten me. Okay. I don't know why I seem to have that effect on people. They meet me and then they're just as soon as they can, they memory hole me. And it seems to have happened here again. Now, in this case, I'm not going to take it too personally, though, because in this case, what's happened is that the AI endpoint, the API endpoint for AI, doesn't have memory, right? If you've ever used ChatGPT, you might become accustomed to it having this sort of long-lived memory of you, and it can relate new information in terms of the old information it's seen. But that's not the case when you deal with the API endpoint directly. So what we need to do is to give it memory, and the way you do that with Spring AI is to create an advisor. So what I'll do is I'll have a map here of string to prompt chat memory advisor. Prompt chat memory advisors. Okay, advisors. New concurrent hash map. And so that means that whenever a request comes in, this.advisors.compute if absent, we're going to compute a new prompt chat memory advisor, passing in a new in-memory chat memory. Now, of course, this is just an interface. You can back that up in terms of whatever implementation you want. And indeed, today is the 9th of April. If everything goes to plan, tomorrow or very soon, we'll have Spring AI M7. And one of the nice features in that release is that there's actually a JDBC implementation of this. So you can store things, for example, in SQL Server or whatever, really, really amazing opportunity. But of course, you can write your own implementation of this interface today. You don't have to wait for M7 tomorrow. So we'll specify that here. We'll specify the advisor. Okay. Restart that. go back over here. And now we're going to say, my name is Josh. Okay, great. What's my name? My name is Josh. Great. So your name is Josh. So it's clearly remembered me. That's good. We're making good forward progress. But I still want to ask it questions about dogs, right? Like, let's see. I wanted it to help me. Remember, we're going to build a fictitious dog adoption service for our fictitious dog adoption agency called Pooch Palace. So, do you have any neurotic dogs? Yeah. I don't have dogs, neurotic or otherwise. I mean, okay, so it didn't understand the assignment, right? Because we haven't really told it the assignment. So the fact that it feels like it has to condescend to us and tell us that it doesn't have dogs is pretty funny. I mean, was there anybody out there who thought the software program did have a dog? I don't know. So anyway, what we want to do is we want to kind of like override the system prompt. The system prompt informs the overall tone and tenor of the AI model when we talk to it. So I'll configure a system prompt here. Okay, var system. Now, look, I actually happen to have a system prompt. I'm going to take that system prompt here. See that? I'm going to cat the system prompt, and then, you know what? That does feel wrong, actually. Let me try that again. I'm going to dog the system prompt. There we go, much better. And copy that to the clipboard system, and we'll paste that in there, and voila, okay? So we'll say default system, okay? Now, it says you are an AI, do I have a DevTools, whatever. You are an AI-powered assistant to help people adopt a dog from the adoption agency named Pooch Palace with locations in Antwerp, Seoul. Wait, you know what? I'm so sorry. Redmond. Surely. Let's add Redmond. Seoul, Tokyo, Singapore, Paris, Mumbai, New Delhi, Barcelona, San Francisco, and London. Information about the dogs available will be presented below. If there's no information, return a polite response suggesting we don't have any dogs available. Fine. Okay. So now it knows the assignment. It's supposed to be acting like a representative of Pooch Palace. So take 2. I'm sorry, but I currently don't have any information about neurotic dogs available for adoption at Pooch Palace. Hey, it works. If you're looking for specific traits or behavior, please let me know, and I can help you find a suitable match. Neat. Okay, so this is better, much better, but clearly we're not there, right? Because it doesn't know about our dogs. And the thing is, we have this table full of dogs, and there's our doggo Prancer, right? So what we want to do is to sort of take all the data in the SQL database and send it to only the records that are germane to the query, of course, but we want to send the subselection of the data that's in the SQL database and send it to the model for final analysis so that it can, based on that, informed by that, give us a response, okay? The problem is the data is in a SQL database, and what I need to do is to find only the things that are pertinent to the query, right? So I don't want to send everything. I mean, truth be told, come on, right? It's only 18 records. All of the big models nowadays will support huge context windows, right? So I could send 18 records, no problem. Heck, I could probably send 1.8 million records these days. Well, maybe not 1.8 million, but I could send like 180,000, right? Something like that. Pretty quickly, right? Not a big deal to send a lot of information. So strictly speaking, it could work, but this is too much, right? I don't want to send that much. And even if I could, it's the principle of the thing. You want to send only that which is required to satisfy the query. And remember, these things have a complexity and or a $0 cost that you have to account for. If you're using the Spring Boot actuator, it gives you observability. You can see how many tokens are being used on average, and you can then chuck that number over to a time series database. Something to give you a dashboard to sort of visualize the ebb and flow of your system and your expenditures. Okay, so I've got the data there in the SQL database. Let's adopt to that. I've got int ID, string name, string owner, string description. Okay, and I need to map these types to the database table, which is called a dog. And I've got in the column in the database table, I've got ID, name, owner, and description, right? ID, name, owner, description. And then I'll create a Spring Data repository. So dog repository extends list of CRUD repository whose primary key is of type integer. So that's my quote unquote data access layer. If you're using Kotlin, then these extra closing curly brackets are optional. So in this case, it's very rare you can do this, right? But if you use Kotlin, you can refactor your data access layer and save 50% of that code. That is to say, 2 lines, right? Which is nice. That's a big deal. That's it's not very common to save 50% on something. Okay. So with that done, I'm going to now take all the data that's in the dog repository and then write it out to the vector store. Okay. So I'll say repository find all for each, and I'm going to say for each dog, I want to write it out to the vector store. I'm going to create a Spring AI document. Okay. So ID parentheses, name parentheses, and description parentheses. Okay. And I'm going to pass in dog.id, and the string I'm creating here is completely arbitrary, right? You can put in whatever you want. There's no schema. As long as it's consistent from one record to another, then we can find things that, all things being equal, are different, right? So we can say vector store.add list.of document. Okay. Now this is a document for a dog, so obviously it is a DOGument. Okay, so there we go. Now, we're going to also configure an advisor. Just like we saw before, if you want to pre-process or post-process requests, you configure an advisor. There are whole hierarchies of advisors in Spring AI. This is like a filter or an interceptor or whatever. We're going to do the same over here. We're going to configure a default advisor called the new question answer advisor. And that's going to basically tell the chat client to consult the model, the vector store. In this case, I'm using Postgres for my SQL database, and I'm using Postgres for my my vector store. Well, I'm not getting very far with it because I forgot to do that, but I'm using it for both. But that's not always the case. You might very well have a vector store powered by any number of other different technologies. Okay. So now, if I go here, and we support them all, by the way. So okay. So do you have any neurotic dogs? It's going to fail maybe because it's taking its. Oh, look at that! It already worked. So yes, we have a neurotic dog available for adoption. Meet Prancer, a demonic and neurotic dog that is known to be man-hating, animal-hating, and children-hating. Prancer has a unique gremlin-like appearance. If you're interested in adopting Prancer, please let me know. Boy, am I. Look at that doggo, okay? So this has worked, obviously, but you might have noticed this took a long time, like forever to start up. And that's because I'm doing these embeddings. I'm writing to the vector store when the application starts up. Obviously, normally you would do this kind of right at the same time as you're doing inserts into your database for the dog table in the first place, but I just did it as a demo here. So I'm going to comment it out by making it false and commenting that out so as to avoid reinitializing the same thing multiple times. Okay, so I think we're doing pretty good. But look, what's the natural next question that you're going to have at this point, right? The natural thing you're going to look for at this point is, when can I adopt this dog? I mean, who wouldn't want to take that dog home and sort of figure out what life is like with that spicy little guy? So, just making sure everything's still where it was. Yep, good, got Prancer. Okay, so the next question is, I want to adopt this dog. And so to answer that, we've given our model access to our data via the RAG pipeline that we just built. I mean, this right here, this is RAG, right? This is retrieval augmented generation, right? And the idea here is I want to give my model access to my data, right? And I woke up this morning and I said, I'm going to write a retrieval augmented generation pipeline. I wrote one line of code and I got a retrieval augmented generation pipeline. What did you do this morning? Okay, just ask yourself that. Now, the next thing I want to do is I want to give it access to my services, my business logic. And remember, this is why the Spring ecosystem and Java writ large is so well and enviably positioned, because most of the organizations are running Java, and their business logic is in terms of Java and Spring, right? And so making it so that stuff, that your model has access to that stuff is a no-brainer. Your services are guarding access to the data that runs your organization, and they control the business logic that runs your organization. So if you can hang AI integrations off of those, you are in a very, very good place. Remember, 90% of AI engineering these days is not building your own model, right? That's not a thing most people need to do, in the same way that most people are not going to write a SQL-based, C-based SQL database, right? They're just going to use something else that's already there. This is about integration, and here, Java and Spring are second to none, okay? So we're going to say, schedule an appointment to pick up a dog from a Pooch Palace location. And we'll say pick up or adopt a dog, okay? And yes, I know I could have used multi-line strings. I'm sad too, but I didn't. Okay, so tool param there's that. And I'm just going to return a simple, a contrivance of a date here. I'll say now.plus 3 chrono units days dot to string. Okay. So I'm going to return a date from now that's 3 days ahead. And I'll say scheduling an appointment for with ID. Voila. Okay. Okay. So I'm going to give my model access to that functionality should and when it needs it. Okay. So I can inject that here, and I can say default tools scheduler. Restart. So now we go back over here. Do you have any neurotic dogs? Okay. Yes, we have a neurotic dog. Okay, that's Prancer. Good. And now, finally, okay, fantastic. When can I schedule an appointment to adopt Prancer from the Redmond location? Okay. There you go. It says April 12th. Today is the 9th. Looks like it did the right thing. Scheduling an appointment. It invoked that. This is neat. Okay. So now we've got this basic ability to do a to sort of invoke our business logic. But obviously this is business logic written in Java, and I've got it located in my Java code base. I might very well have another service or another integration. I might use .NET, for example, in which case I'm going to want this to be centralized and reusable. So Anthropic, way back in November, you remember November, don't you? It's been a little while, but they created this new protocol called MCP. And so the idea is you have a way to stand out business logic, to expose business logic and make it available to your models. Okay, so I'm going to create an MCP service. There's 2 different flavors of MCP. There's HTTP, and which is actually based on service and events, or standard in and standard out. I'm going to use the HTTP variety here. So we're going to say 8081. And in order for this to work, I'm going to go over here and I'm going to just cut and paste. Okay, this is not something. Don't copy and paste. Cut and paste is fine. Copy and paste. That's where you get bad code smells and people start asking questions. Okay, so we're going to paste this over here. Okay, I've extracted. Do not repeat yourself, right? And then I'm going to tell Spring AI to extract and expose all the good stuff in the application context as an MCP service. Okay,
Josh, it feels like you're vibe coding now.
Yep. And I'm going to do this. We'll say that. We'll do this. By the way, how much time do we have? Are we almost out of time?
Out of time, buddy.
Okay, good. Let's run this. Okay, close that. And finally, this will point to that now. So we'll say bean MCP client, return MCP client dot sync new HTTP. Okay, HTTP localhost 8081 dot build. Okay, var MCP sync client, and return MCP dot initialize. Okay, so there's this, and now I'm just going to tell Spring AI to use that for its tools. Okay, so we'll say this new sync MCP client or whatever. What did I call it? I called it scheduler. Call it MCP. Okay, sync. What is this? Oh, MCP sync client.
I think you're gonna have to wrap up in 30 seconds.
Go.
This doesn't work.
No problem. We got this. Why wouldn't it work? Okay, here we go. So next question. Do you have any neurotic dogs? Okay, that's got it. Now, next, when can I schedule an appointment to adopt Prancer from the Redmond location? It says April 12th. Go back over here. Go over there. You can see in the scheduler, the MCP service is there. So my friends, with this, we've managed to create an AI application using MCP. There's thousands of MCP services out there. The next natural step would be to build some agentic patterns. The good news is agentic just means using AI to drive other AI. And it's just basically think while loops, think control flow in terms of the stuff you've already got. There's never been, my friends, a better time to be a Java and Spring developer. With this code, we could easily take it to GraalVM, deploy it to Azure, and be up and running in no time at all. I want to thank you for your time, and have a great day.
Thank you so much, Josh. This has been amazing. I'd like to welcome on stage our next speaker, Daniel from Red Hat. No, let's let's bring Josh back, please, quickly.
Can you hear me?
Oh, Josh dropped. Okay. Well, thanks, Josh, again. Hey, Daniel. Good morning. How are you?
Hi, Bruno. Yeah, thanks for having me. It's a little bit middle of lunchtime though in the East Coast.
All right, awesome. Well, let's make sure that you deliver an awesome presentation before you feel hangry.
Sure. Yeah. So you can share you can see my screen right now.
Yeah, we are good to go. I'll leave you now on stage. Thank you.
Perfect. Yeah. Thank you so much, Bruno. Hello, everybody, and good morning, good afternoon, depending on where you are. So my name is Daniel O. I'm going to talk a little bit about the boosting AI developer experience with the Quarkus and LangChain4j and Azure OpenAI. You probably know a lot of demos and talks around AI infused or AI power application today or tomorrow or in the past. But I'm going to really show more like a live coding stuff. So again, my name is Daniel O from Red Hat, developer advocate role, and I'm Java champion, and also long-time Cloud Native Computing Foundation, also known as CNCF ambassador, and among others. So there are a lot of community contribution activity allows me to see and meet a lot of awesome developers and platform engineer in this area. So here's my contact info. Daniel030. You can find me Google. You can actually search me in Google and then Twitter, X, and YouTube, and GitHub, whatever you want. So before we jump into live demo, I'm going to talk a little bit about some AI services, how to design. So fundamentally, it's some kind of ambassador design pattern. So you can design and try to approach how to define your interaction between multi-LLMs and your AI application. So you probably have multiple language models for chatbots and tools, and like text to image or text to video, depends on your demands and requirements. So the thing is how to make it easier and faster in the more standard way, communicate between your AI application and LLMs. So today I'm going to use a Quarkus, which is really awesome. Try to reduce your code modification or code development stuff, and then bring into more configuration model, which is a pretty much easier Java developer. You can just define whatever you want, your capability for AI application development in your application property file or YAML file or COM.xml or gradual model and so on. So we're going to use Azure OpenAI, but Quarkus, a lot of you have a multiple AI platform like OpenAI or Llama and Hugging Face and among others. But I'm going to talk about and showcase Azure OpenAI. So starting with that, you can actually have one dependency, for example, Maven project, LangChain4j, because Quarkus already integrated LangChain4j pretty much easier way rather than any other Java frameworks. And then you're going to start add some like a prompt with some annotation from LangChain4j. You're going to just define your new interface for your AI new service, which is like a REST AI service annotation on top of the interface. And you can inject a dependency injection. Of course, you need to set like an API key targeting your LLM model running on some platform. I put my API key with secret on my embedded variable to access my Azure OpenAI. And then you're going to add like a more advanced AI capabilities such as tools, agent, and like agentic AI application like MCP protocol, also and functioning calling. So for example, MCP, Josh, he just really bit talk about that. And the Quarkus also allows the Java developer to integrate and implement MCP server, just connect to external predefined MCP server, but also you can create your own custom MCP server on top of that without like almost zero code, and put in the your configuration like a MCP. So what is your external MCP server with some like a command line like a npm or some of the Python stuff. When you need to run your custom MCP, you actually implement pretty much easier to develop your custom MCP client and server stuff. So embedded also RAG stuff to you probably know and heard a lot of times what RAG is, how to make it better response from your AI models. when you inject your like a domain-specific document. So fundamentally, you have to implement two pieces of the RAG capability. One is how to ingest the document into your vector store. You define some of the like code snippet stuff, and also you're going to retrieve that data from your vector store. That is another step. How do you define the retriever on your Java application code? Of course, Quarkus router, you have like a fundamental CDI injection and so on. And then you can define your AI services, which tool you, some agent you're going to use that with the retriever, just like this code snippet. And then a lot of developers, wow, this is so much not easier to build my own retriever as well as ingester. Don't worry, there are great, more easiest way to retrieve your document on your Java application, implement the RAG capability. That is easy RAG, part of LangChain for J. You're going to just add the LangChain for easy RAG in a Quarkus application. And the only thing is, by default, you have to add the path where your documentation exists. Super easy. So here's my demo architecture today. So I'm going to try to showcase the several demo as many as possible today. And I'm going to try to new simple AI application with the Quarkus, which basically have some chatbot stuff. And then I'm going to create another AI application, which has some more advanced capability, for example, RAG. And also, even if I have enough time, I'm going to try to add some kind of new tool to send some email using some mailer, as well as some Quarkus, some other mail field extension, and so on. So the whole AI application, I'm going to just connect to AI model, multi-AI model on top of the Azure OpenAI. And also, I need to use Azure AI Foundry to deploy model on top of the Azure OpenAI. So here's my demo repo, the github.com Daniel030, and the Quarkus Azure AI Git repo. Yeah, you can feel free fork and clone it, and then try to replicate this application on your local machine after this session. If you have any issue, please feel free reach out to me directly, or you could more than welcome to open the pull request or issue, and I'm happy to address that kind of stuff. Okay, I'm going to start my presentation here, and then so starting with that, this is my Azure cloud based on my credential. I already created Azure OpenAI. You can see that there are some overview. Here's my endpoint and my key, and then you can see that endpoint among others. And then in order to deploy model on my own Azure OpenAI, I have to go to Azure Foundry portal, which is this one. I already deployed two models. One is a GPT-4o mini for my chatbot application, and the other one is a text embedded ADA, the W2 model, which is an embedding model when I use the capability. So it's really great. You can find all like a URL. And for example, and there are some examples as well. You can have a Python, JavaScript, and REST API, and then Java code, and you can change the SDK and authentication way. And then here's a code snippet and how to actually implement and your Java code as an example. And they're all code snippet. So there are several ways you can scaffold new Quarkus project. You can go to maybe easiest way, go to Quarkus.io and then go to the Quarkus.io. It's a project starter or generate new project. You can actually change whatever you want, like an artifact. For example, here is like a Quarkus, Azure AI. You can change that, and then Maven, Gradle, and then Java version. And then you can generate the example. And the one really interesting part, we actually Quarkus team categorize some most popular, like a common use cases when you develop Java application. So one of the biggest thing here, AI infused service, it automatically added to dependency as from Quarkus ecosystem. One of them is LangChain4j, OpenAI, and CRaC. This is we understand most Java developer wants to create a new AI application with the access to OpenAI, but also adding some RAG capability, more developer responsibility rather than fine-tuning by AI engineers or data scientists. You can unselect, and then you can actually find Azure OpenAI. You can actually add one, and you can see that two application, the extension, and you can actually generate and download and then new project. So today I'm going to try to use Quarkus CRI, which is my favorite. I don't need to remember all parameter or extension name. It's pretty much easier for me to create a new Quarkus project. Let's say project name Quarkus Azure AI. Let me try to create a new one. Okay, and then I'm going to create a new project. And then it automatically generates a simple project. It's not AI application, but this is a pretty simple application. And then always first thing first, I'm going to run Quarkus demo, which gives me live coding capability. And then whenever I change it to code, I don't need to even start, restart, compile, rebuild any like an inner process. It automatically just done by Quarkus framework. So Quarkus is running. Probably I need to change my Java version. My local is now 24. I changed that. And then as you can see, I just changed my XML and it automatically starts Quarkus. And I don't need to do manually. It's significantly reduce my development time, like a developer productivity stuff. So when I go to dev UI, and then I'm going to try to make it bigger for you. And then there are REST API, and then hello is a simple application, hello world Quarkus REST. And then there's nothing in there. That's very simple, like a hello world. So now I'm going to add, let's say, Quarkus, add extension, LangChain4j and Azure OpenAI. So I'm going to try the new extension, and probably Quarkus extension. Okay, try this one. Okay, I just add a new one, and then when I go back to dev UI, and then you can see that. Let me try it a little bit smaller for me. Okay, now you see a bunch of the new extension. You can see that, for example, Quarkus LangChain4j, which is good. So. And then I just need to create the one simple chatbot rather than like a fully qualified some front-end application. So to do that, let me try to go to Java directory and then create a new interface. So let me try to change the interface. I'm going to try the new bot. And then I'm going to register this AI service as I mentioned earlier in my slide deck. And then I'm going to try to create say, write a job for me. And then like a string, like a topic, and integer, like some lines. That's it. And then I just need to do two things. One is the system message. It's the initial message sending to my LLM to define the scope of LLM and some kind of behavior. So let's say you are a professional comedian in the United States. Okay. Okay, so that's it. And then I also needed to set the user message. Is every time when I prompt like a user input, it already sending to the LLM. So let me try to define a little bit interesting part here, like a write a joke about some topic, which is just some automatically bind from my parameter about in less than nice. Okay, just it. Just pretty simple. I just set up all prompting engineering stuff, system messaging for initial message to LLM, and then the user prompt with some annotation. And then I'm going to go to application property. I need to add to Azure OpenAI configuration to access here. So you can see that I just put in my API key and AI version and which is deployment name. And I go back to Azure, and you can see that my resource here, like a DOH OpenAI and Azure OpenAI with a resource name. Go to detail. Here is the model name. So all from my Azure stuff. And then my Quarkus dev mode still running. And then go back to Quarkus dev UI. I'm going to quickly replay. And then now you can see that chat menu, which is great because I don't even enough time today for this demo for 25 minutes to create a fancy front-end application. But Quarkus actually give me some dev UI, which is great for me. I just verify my the AI chatbot is working. So this is my like a system that you are professional. And then let me try to add like an Apple and then like a 10 eyes. And then go back to my Quarkus demo. You can see that some logs here. Oh, your system message here, your user message, user Apple. And then it got us some, oh, this is just some joke, Apple, age old debate, Apple, some of the blah, blah, blah. But I don't know, this is just super funny, but this is actually working on my application, which is awesome. So I just need to give it some like a couple minutes to stand up new application. So let me give you some little bit interesting part, like try to add the tools more advanced stuff. So let me try to start this new, this existing one, and then go back to, and then let me try to create a new application right now, and then Quarkus, Azure, AI, and the RAC thing. I gotta add the extension at the very beginning is the Azure OpenAI. One is that, and the other is Easy RAC, and then now is like access by the UI. I just put in the like a Borex, the HTTP, some kind of thing. And then I'm gonna try to go to right directory and open my IDE here again. And then one interesting part, the Quarkus automatically generates some like a RAC sample application. You can see that now I have some example document which should be ingest to my vector store. So the multiple type of format, as an example, ODT, some of the old format, your Linux or Fedora stuff in the text file, PDF file. When I open one of the text file, this is just some kind of retirement money market saving account, some offering. An example, hey, there's there's no like a monthly maintenance fee. And then another thing is a saving account, like a $0 ATM transaction and a surcharge fee. So some kind of new offering for like some finance company. So when I go to application, and the bot is automatically generate, just like I wrote it manually in the previous demo. And the system message, you are AI named the bot. Let me try to change that like that. And then answering question and finance product, and then some of this more detail here. In the user message, literally wiring your question directly, and that's it. So in order to access that, let me try to add some RAC thing. Let me try to delete it. And first of all, I'm going to try to Azure OpenAI access stuff. This is a GPT-4o mini. But as I mentioned earlier, when I go back to, again, here, my model deployment, I have another model, which is the embedding model for my RAC stuff. So I need to add the RAC, the embedded model configuration in the Quarkus application, which is very simple. So like a embedding model. So here's the embedding model. I'm gonna just use the different annotation here, like a parameter. Hey, this is my chat model, basically access to GPT-4o mini, and this is the embedding model. The same is a super different model name, and then like a probably different key, but it's technically I'm using same key for both model because these two models deployed in same my resources in Azure OpenAI, and then here's the resource name. This is the same thing. And then one last thing is the EG-RAC setting here, like some EG-RAC. This is a actual directory path. And then I'm going to reuse embedding some caching stuff, and then some min-max size and redraw some stuff. Alrighty, and then I try to open my terminal window, and I'm going to run my Quarkus tab. Hopefully it works. And then once it works, I'm going to go to my dev UI again. Okay, so Quarkus is running. Go to dev UI. Okay, not ready. Okay, probably right now. I got maybe go to really fast. Okay, here's chat, and then click on chat. Okay, here's my system message. You can see that my name here. And then what about the tell me about the standard savings account? And then when I go back to my terminal, and then you can see that it automatically user prompt augmented by like some RAC stuff here, all from my context, the document. And now you can see that in the WI too, I actually prompted this one question, but this is all detailed from my document, from my RAC capability, and AI actually answer this kind of stuff. But WI actually show what happened behind the scene, but your actual chatbot should be just to show your user prompt and then answer from AI model, which is good. So I think have a couple more minutes before I jump into the question and answer. Probably I can add one more thing, like a tools. So I'm gonna open a new terminal window here, and then add to, let's say I'm gonna try to add like an email capability as a tool. When I ask some question, which question automatically ingest and retrieve from RAC, and then I'm gonna sending that result from AI model and sending to my email, just to make sure to save that information, but also sending somewhere, like some email communication stuff. To do that, Quarkus also provides some email capability as an extension, and some kind of some markup email mailer as well. So I just need to add some mailer and mail feed. Mail feed is some kind of like some fake your email, some application. So it automatically restart by Quarkus app, as you can see. And then, so one of the good thing is it automatically, Quarkus actually using out-of-box feature of test containers. So it automatically start by Mayfield as test container. So only thing I did I just add the extension, and Quarkus automatically detect and then try to stand up test container by default. I don't need to add some configuration. Hey, where's the container image, and then where's the test container key and value, my application property or YAML file, or I don't even add some code inside my Java application, like a method or a class and so on. So when I go back to dev UI, and then now you can see the mail feed. Okay, let me try to reload once again. Okay, now you can see the mail feed. It's like a fake my mailbox. There's nothing in there. And then I needed to try to create a new tool class here. Let's try to class here, email service. Okay, and then make sure this is like a application scope. And then I'm gonna inject mailer. Mailer, okay, mailer, and then I'm gonna try to like a starting content, and then make sure this send the details to email. That's how this tool invoke from prompt, and then like a mailer, and the sending to mail sandwich, and from like a JDConf xx.com, and then so new finance info for you. This is a mail subject, and the actual body is content as a parameter. I'm gonna to set from, which is like a Daniel O and redhat.com. Okay, looks good. And the one I just set it a new tool. It could be a database connection, whatever you want. And then I just needed to set the tool on my API, the AI services, which is email service class. That's all. Okay, hopefully it's working. and then go to, let me try to reload. Just that way, I don't need to actually do that. Just make sure everything's okay. And then, okay, so tell me about the retirement money market and send the details to my email. Okay, go back to my terminal window. You can see that there are already embedded stuff. And then when I go to the retirement money market, and then there's no maintenance fee, I just already showed that. And then go back to here. Okay, now I can see that here is I tell me about this is the originally I prompt, and then so the CRaC augmented your some of the detail, which is to make you better question to your AI model, and then two invoke like a sending emails, which is invoke email service Java class here. And then I sent the money account to email, and then like some of the question answer from AI model. And when I go to mail field, and then I'm going to load, and now you can see that I got a new like from JDConf xxx.com, and then like from Daniel O. And then you can see the new finance info for you, and then you can see that exactly from my AI model. Previously, you can see that in your chat box window, dev UI, but now I can see that thing on my the email and interface application, which is just so cool. So I think I'm done. I have a more demo if I have enough time today, like some MCP or more agentic stuff. But I think this is just, I feel this is still good enough for Java developer. They really want to find some practice how to get starting AI infused application development with the Java and Quarkus, and then like Azure, OpenAI, some of the multiple models, and then keep adding more capability from beginning chatbot and adding more capabilities such as like a RAG and more like a prompting engineering, as well as some tools. I just use the email, but you can actually connect to multiple tools, not only one tool, like access database and store some stuff or retrieve some data and combine and that info from database or messaging broker, as well as original answer from LLM model, and they put together and then write some new email content and then sending to your end user, like a customer service and so on. Okay, I think I'm done. I'm gonna just share my screen once again. And then here's my demo URL. Again, Daniel30 Quarkus Azure-AI. Please feel free fork and clone, and then follow my Git repo as well. I'm gonna keep putting on some great and helpful example with the Quarkus and AI and among others. And that's it. So is there any question today?
Thank you so much. This was an amazing presentation, and it's interesting to see the we just had Josh Long presenting to Spring developers, and now you bring in Quarkus approach for Jakarta and Quarkus developers using LangChain for J, which is perhaps the most well-known LLM framework or AI framework right now in the Java ecosystem. What is like the one thing that you feel like is still missing in the Java ecosystem for developers to build AI applications?
Oh, that's a really good question. So I think so. Except for MCP, it's the Java developers ecosystem still lack of some like agentic library and ecosystem compared to like a Python ecosystem. There are many frameworks like AutoGen or Pydantic AI, among others. For Java, we probably have some big stuff like MCP right now, rather than others. So that is maybe still not super mature stuff. Yeah, agentic.
Yeah, no, interesting. Our next session is with Adib, who will talk about Spring AI. So I wonder, Adib, you gonna join us?
Thank you so much, everybody.
So Daniel, Adib, what do you feel like is the one thing missing in the Java ecosystem for Java developers to build AI apps? Oh, Adib, I think you have to unmute.
Hello, can you hear me now?
Yes.
Excellent. I think the main thing that's missing is an enormous amount of experimentation. We simply haven't been doing as a community AI as long as the Python community has. And, it's easy to go out there and basically say, I'm going to copy a Python framework or an approach that works in Python. But we all know different programming language communities go about doing things in a slightly different way. And so I think like finding the true Java-centric way of building AI applications, it's still an ongoing experiment. It's exciting times. So it's going to take us, I think, a lot more experimenting.
I wonder if you could go into ChatGPT and just say, hey, ChatGPT, what do you think is still missing in the Java ecosystem for AI developers to build AI apps? And, just go with it. Let's just roll the dice and hallucinate a little bit on what the AI might think, statistically speaking, what's still missing.
I don't think there's anything like that's blocking. I don't think there's any blockers today. Like not at all, like zero. You can call models, you can call vector stores. Java has the richest ecosystem of any community in terms of connectors to different data sources. So I don't think anything is missing. It's just that people sometimes may feel like, well, the Python folks have been doing this for longer, so it must be more mature. But that's about it.
Yeah. So you're going to talk about Spring AI. Is that right?
I am going to talk about how to build agents with Spring AI. So very much like educating our audience on like really what's an agent, what are the different approaches and techniques for building agents. The focus of the talk isn't like 90% I want to teach you how to use Spring AI. It's more I want to teach you how to think about agents and how to approach the building of agents as a Java developer.
Awesome. All right. So I'll leave the stage to you now. See you in 25 minutes.
Excellent. Thank you. Feels like, hey, 2025, that's the year of agents. You turn on the news, and you're going to see different articles and different news coverage about the impact of AI and how it's going to transform our society. That's why we're all here talking about it. So let's actually first distinguish what's an agent. Let's say you have a standard kind of task you want to do. You need to book a business dinner with some customers. So what would you do? You might go out and open an app like OpenTable, and then you go clickety-click through, and then you find the restaurant you're looking for. But really, wouldn't it be better if you could ask the restaurant reservation app something like, I have a business dinner tonight. It's at 6 p.m. I have 5 people coming. One of them is vegetarian. And I have a meeting till 5:30. Find me an available restaurant that meets company expense policy. I think I would much rather type that prompt rather than having to navigate a GUI for the purpose of finding and booking that dinner, right? And so if we did have an agent that was a restaurant reservation agent, what would it do? First, it would have to figure out like how to find you a restaurant within 30 minutes of your of commute time to get to it, because you're going to be at the office. But how is this agent going to know where are you going to be? Where is your office located, Adib? So it has to figure out to ask me, Adib, where are you going to be at 5:30? Or maybe it has access to my calendar and it can check that. Now, presumably, restaurant reservation system has access to the restaurant's menu, so it needs to check the menu to see, hey, are there good, tasty vegetarian dishes on this menu? What's the company expense policy? Again, it doesn't know anything about my company, so it might need to ask me, is that like, and I might respond back with something like, it's $100 per person. Now, we're looking for something that's highly rated, so that it knows about. It has to have capacity, but also there's some implicit goals here. For example, you don't want to end up at a restaurant that's very noisy because you're trying to have a business conversation. So you don't want something that's too noisy. So this idea of the agent kind of taking your prompt and figuring out what are the goals that you have, those are the things that that distinguishes, in my opinion, an agent from just an application that uses AI. So let's actually take a look at what we like to call the, kind of the continuum of the different kinds of applications you can build, because I find there's a lot of like confusion sometimes out there about what it is. So if I asked any of the developers on the call today, "Kay, can you build me a restaurant reservation system?" Everyone, I'm sure, knows how to put together a database plus an API plus a front end in order to build out a restaurant reservation application. But then you're like, hey, you know what? Maybe I'm visiting a big city like New York City. I open it up and I see there's 10,000 restaurants. Maybe we should have some machine learning. And what the machine learning model is going to do is going to make predictions about what restaurants is Adib likely to want to visit. Like what's his taste? Well, how is it going to figure out what I like? What's going to do it based on my previous booking history? It might also want to have a machine learning model to predict how good of a customer is Adib. Does Adib have a habit of booking restaurants and not showing up, right? We should tell the restaurateur, the restaurant about this, so maybe they don't wait too long for him to show up, right? So these types of machine learning models have been something that our industry's been doing probably for the last 10, 15 years. And we used developers, we used like data scientist teams who kind of know the linear algebra and calculus, and they know how to train a model. But they're really predictive models, machine learning models built on data that we have in the company. And that is a very different skill set that what we typical Java developers have. We're not really remembering our calculus and linear algebra. Some of us do, but most of us don't. And so the next step up in this kind of maturity model is like, hey, I just want to build a Gen AI app. Maybe what I'm doing is taking the restaurant reservation. I just want it to handle a simple task. Like the restaurant reservation app has a screen. And in the screen, I can like click a button to select the cuisine. I can click a button to select the time that I want. I can click a button for the number of people. So what if I just built a prompt that said something like this? Here's the user prompt. From this prompt model, please extract for me the type of cuisine, if you can tell it, the number of people, and the time, and the location, right? And so effectively, with this Gen AI app, you're using the model as a user interface. It's kind of like how you use a touch screen or how you use a web browser, but it's not trying to solve for a set of constraints that are implied or somewhat explicit. So that's like, but for the skill set that you need as a developer, you just need to know how to call a REST API. If you can call a REST API, you can build a Gen AI app, right? You don't need to go through this step right here where you have to remember calculus and linear algebra. You can jump straight from here all the way to here. But once you've built your first Gen AI app, it's not like, it's very exciting to say, can I make that Gen AI app like better? Can I make it autonomously solve for a set of constraints within the user's desires? So that, I hope, is giving folks a chance to understand, like, what do we mean when we talk about an agent? So keep this idea of the restaurant reservation agent as we go along, okay? So when we talk about these agentic systems, we're really talking about using the AI models to interact with the environment, okay? So for example, the restaurant reservation agent, I told it that I'm going to be at the office till 5:30. So how does it know where my office is? Now I tell it, it knows where the restaurant is at. It needs to figure out, well, how long is it going to take Adib to get from his office to the restaurant? So it needs to perform actions in the real world. Like, for example, maybe it should book me an Uber or something like that, right? And so this is where there's two stages to building these agents. There's a stage where, it's a planning stage where the agent is going to handle reasoning to kind of come up with a plan and what actions to take. But then there's the actual action that you need to take, which are the tools. And that idea of using the model to come up with a plan and then using tools to execute the plan is kind of central to this whole thing. And those two things where you have, they come together in what's called the agentic loop. So I don't know if anybody's already covered this in the conference so far, but if you've seen it, well, this is a review, right? So this idea of we go to the model from our agent, we ask the model to come up with a plan with a set of constraints, and then that's the reasoning planning step. And then we go through and then we perform some operations, and we might need to go through this multiple times to get the result we want. Perhaps the agent is going to say, Deep, I found 4 possible restaurants. Which one do you like, right? So there's an element of memory and kind of remembering what has happened along the way in the interaction that you also have to solve for. And so if you're new to AI or you haven't had time to look under the covers to understand, like, what is this thing called tool calling? So let's actually quickly review this with some nice diagrams. Let's say I go here and I say, what to wear today in Amsterdam, okay? And the prompt that's going out doesn't just have this part up here where I'm hovering my mouse. That's actually what the user typed. There's also a tool description. And you can see here this green area says, I have a tool called Get Weather. It has a description, and it has an input of city name. Okay, so that's going to go to the model, and the model is trained by Azure and others to basically be able to figure out that in order to answer the prompt, the question the user asked, it might need the information from this tool. So what's going to happen is the response that's going to come back is going to say, the model is going to tell to the application, okay, you told me you've got this Get Weather tool. Can you please invoke the Get Weather tool and pass for the city called Amsterdam? So the model is deciding 2 things: what tool to use, number 1. Number 2, what the arguments to that tool should be. And that is what's kind of happening in this scenario. And so now what happens is that the application is going to first take the tool response. Okay, it's 12 degrees and it's raining. And it's going to send the old history, so the whole entire previous interaction, because the models themselves are stateless. They don't remember anything. You have to kind of give them the whole entire context every time you invoke them. And so you can see now we have the previous what should I wear today from the user, plus here are the tools that are available. We have the response from the assistant saying, please call this tool, and this is the parameters, and we have this new user input. And then from that, the AI is going to come back and say, okay, you should wear a jacket and get an umbrella. Now, I hope this gives you a sense of what these tools do. These tools are things that you write yourself. This is code that you write, but it's code that allows you to adapt to on-demand offer the model data that is not part of its training set. So let's talk about, see what this can look like. This pattern, this tool is like the foundational thing you need to build agents. And so that's why I'm covering it in a little bit more depth to explain to you what's happening under the cover. The model does not call your database. The model does not call your API. The model will ask your application talking to it to access the database, will ask your application to access the API. So how are we going to turn this into real world stuff? Well, we're going to use Spring AI. Okay, what is Spring AI? It's an application framework. It's portable AI service abstractions. It's really all about developer productivity. And we have a very simple goal. We want you to be able to keep up with all the latest developments in the AI world. So let's quickly take a look about how you would code that tool that I showed you earlier. So if you look at this one here, you'll notice that you've got a pretty simple looking piece of code like Get Weather. And what's different about it is if you've used Spring before, you may have written something like @REST controller with @request body and all this type of stuff. We have a bunch of annotations that allow you to describe to Spring AI what this adapter code is doing. So in this case, we're saying, well, this particular function called get temperature, it's a tool. And this tool has a description, get the temperature in Celsius for a specific location. And then we can specify that there's a tool parameter with the inputs that are needed, the longitude, the latitude, and the name of the city. So we're asking for 3 inputs. And then what we're doing inside is what you would expect. We're calling out to an API that takes a longitude and latitude and retrieves the weather report at that location. And then what we're doing is we're returning that weather response. So now what happens is that you've got this tool, it's sitting there in your application. And the question is, I'm going to make a request to an AI model. How am I going to do that? Well, there's this concept called a chat client that's built into Spring AI. So you can see here, I simply say, I've got a chat client.prompt, and I give it a tool. And what tool am I giving it? Well, I'm giving it a list of tools, including the weather tool here, which we're saying ... because you had done like new weather tool or gotten the bean or something like that. And then we can put our user request, what to wear today in 2 different cities. We make a call and we get the response. And that's really all you need to do to get this. So this goes back to my earlier statement. You don't need to remember calculus or linear algebra, or you don't need to know Python. You just need to know how to call a REST API. You need to know how to describe code. And there's a very idiomatic Java way of doing that. And that Java way of doing it is really what we're after in exposing it to you in the Spring AI framework. And also not just in a Java idiomatic way, but also in a very Spring idiomatic way. So it's consistent with the rest of Spring portfolio, right? Now, there are 2 types of these agentic systems that one can build. One is kind of like workflow-based agents. And these are where you have LLMs and tools that are orchestrated through predefined paths, right? And those are, for example, let's say you're trying to offer a product recommendation, or like that restaurant reservation example. So there may be like a workflow that you should happen. Like I should check for location, if it's relevant, the travel time. I should check for allergies. I should check for various other things like noise level. So whatever are the parameters that normally people would need to check for, you might pre-program them in as things to see if they're relevant for that prompt. And that would be more of a workflow-based approach. The other one is an autonomous-based approach, whereby you're basically letting the agent kind of completely come up with a plan 100% on its own, and then execute that plan in whatever way, shape, or form it wants. Now, no surprise here, if you think about it, the workflow-based approach is not going to require as much capability from the AI model itself. Like if you want to do the 100% autonomous agents, you really need an AI model that is really, really powerful. And so at this point, I think, I'll just take what Anthropic is saying in their Building Effective Agents blog post from December of 2024, just a few months ago, where they're basically pointing out that what they're seeing work in the real world right now are composable patterns rather than complex frameworks, and more of the workflow-based approaches. The reason why is that the workflow-based agents are a little bit more predictable and consistent for well-defined tasks. At this moment where we are in the industry, let's be honest about it. Most applications don't have AI capabilities in them. Sure, we're lucky, we're developers. We are spoiled for choice. We can choose to use GitHub Copilot, we can choose to use Cursor, we can choose to use Windsurf, we can choose to use Claude, we can choose to use like one of an infinite amount of tools out there for like assisting us as developers. But let's say you're a sales team working for a company, and you have a meeting coming up with an important client, and you want to find out like what is the maximum discount I should be able to offer this important client. And you may want to look at factors like, what inventory do you have that hasn't sold yet, and what is the purchasing history of this client, and various other things. So if you were to think about it, wouldn't it be great if you could build like a sales copilot for your sales team so they could use it? Now that sales copilot needs to be integrated into the application that your sales team is using, right? And that means that you as a developer of that sales application need to be able to go in and enhance it. And so I think the opportunity to build these workflow-based agents today is a lot bigger than the opportunity to build the fully autonomous agents. And I would encourage all of you to start there because you're going to get better results. So what are some of these things that you can build? So right here is a screenshot from a set of diagrams from a bunch of the patterns that were put together and published in that really nice article from Anthropic. We also published, Christian Solaf from the Spring team also published an article showing how to implement all those patterns with Spring AI. You can see the links on here. to do this. So you'll see things like, for example, chain workflow, which basically means I'm going to break down I'm going to take the input and I'm going to figure out what are the steps that need to happen, and I'm going to execute those in order. You could have a routing workflow where you can look at the prompt. You're like, what kind of issue is this? Oh, this is a customer that wants to return their product. This is a request to troubleshoot something. This is a request for a discount. So you know where to route the request. You might want to have something where you're running these tasks in parallel and then you aggregate them, right? That's down here. You might want to do something where first you orchestrate and you figure out what are the steps that need to happen, and then you bring together all the answers. Or you might have like this evaluator optimizer where you have the LLM generate a solution, and then you have another LLM that basically says, okay, let me see if you did a good job or what's wrong with it, and you kind of go through this loop a few times. So what I want to do next is kind of like jump to the code and show you how you could implement one of these. So I'm going to go here to my IDE. I hope everybody can see the IDE. I assume you can. Speak up if you can. And the code here, first of all, let's actually see where this is from. So if we look at this is from the GitHub Spring Project Spring AI examples. We have a I don't know why my browser isn't coming up, but oh, there it is. Okay, this is a place where you can find lots and lots of examples about these, including this agentic patterns here, which is what I'm one part of the repo that I'm focused on. You can see the rest of the examples in here. So let's go back to IntelliJ. And within this, there is an application here, and I'm going to focus on the orchestrator worker. So I've got some breakpoints set up. So let's just take this and debug it. All right. And then here is you can see, first of all, this isn't like some giant piece of code. There is like, I don't know, 200 lines of Java code really outside of the main method. And it's Java, it's wordy, it's verbose. So this is not very complicated. So let's go back here to where we're at. So we're going to start by creating an orchestrator workers. And then you're looking at this and you're like, hey, is that a class from Spring? No, it's not. This is just how easy it is. Like a lot of the time when you're building these, you don't need to reinvent the wheel. You've already got a mature ecosystem of things, and you're a developer. You can write code, right? So what we're doing here is we're just representing that pattern in a class called orchestrator workers. And so we're asking it to write a product description for a new eco-friendly water bottle. So let's see what happens if we continue on. So what are we giving it? Well, we're giving it a chat client. Chat client is the central interface in Spring AI that you use for interacting with any type of AI model, whether it's a chat model or other things. And so we're taking an orchestrator prompt. So let's actually just get through these lines of code here and look at that. So the orchestrator prompt is basically saying, analyze the task and break it down into 2 or 3 distinct approaches. So let's actually see it up here. It's you can see it a little bit more easier to read. So we're giving it a task that's being passed in. So you'll notice here, I've got this like curly brace thing. Please substitute the task in this one. And then we're asking it to return a response like, here's my analysis, and here's the tasks needed for that. Okay, so we're looking for write a precise technical version that emphasizes specifications, write an engaging, friendly version, and on and on and on. So that's to give it an example. So we'll go back here, and let's step over this. Oops. Okay, so now we're calling the process. So our task description now is write a description for the eco-friendly bottle. So our step 1 is we need the orchestrator to take this, to take the orchestrator prompt, which is telling it to kind of come up with some tasks based on this plan for how to do the analysis. And then what we're doing is we're passing our task description, we're calling the model, and we're going to get a response. And let's actually see what kind of plan it has decided to. Oh, we're waiting for it to come back. All right. So let's step over that and Step over. Okay, so let's take a look at our console. Okay, so you can see here product description for an eco-friendly water bottle. Requires balancing technical specification with emotional appeal. The key aspect includes sustainability features, practical benefits, environmental impact. Different approaches can target different consumer motivations, blah, 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 blah. Okay. So that's one thing that it came back, but it also came back with a list of tasks. So you can see here there's a technical environmental task where it's creating a specification-focused description for highlighting the materials, manufacturing process, recycling, blah, blah, blah. There's another task which is lifestyle-focused, where it's trying to kind of develop a nice description emphasizing how the bottle fits into the eco-friendly lifestyle. So we've got two tasks in this example, right? So now what we're going to do is we need to take each of those tasks and we need to send them to the model. Well, how do we do this? Do we need anything super specialized? No, we don't. We have a list. And if you have a list in Java, you can just say list.stream.map, and I'm going to give it the task. And I'm going to say, okay, I've got a chat client. So let me create a prompt based on the original task, the task type, and the description. That's what I'm going to send to the AI. And it's going to come back with a string response. So let's actually continue with this. Okay, so we'll wait for it to execute and come back. Oh, and what do we have here? What did I do? I think I pressed it too many times. Or maybe I timed out because I was talking. So let us... Oh, we're waiting on something? Okay. All right, so...
Yeah, Dave, we are, just so I know, we are at time.
We're at time. Oh my God. Okay, I got one final slide. Is that okay? All right. So I just wanted to basically, now that I showed you this, I just wanted to wrap it up. Just say, look, there's two approaches to build one of these agentic frameworks. There's a bottom-up approach, which is what we've taken with Spring AI, where we wanted to build the foundational the foundational abstractions first for how to do portable model access, capture reusable AI logic, observability, vector stores, and then allow you to implement these AI patterns on top of those foundational patterns. And our goal is to offer first-class foundational and agent abstractions. There's another way you can build an agent framework, which is to just build it top-down. You build the high-level agent framework first, and then you figure out how to make that agent framework work with all the different model providers, and then you iterate on the abstractions. So the goal of this one is to just let you build agents, whereas the goal of the bottom-up approach is to give you multiple levels of abstraction. So thank you. That's what I wanted to share with you today.
Awesome. Thank you so much, Dave. This was a great presentation, and I'm sure that developers have now a much better sense of building agents with Spring AI. But not only that, you gave lots of interesting thought process on how to think about building agents and when and where and how they are usable in applications, especially enterprise applications. Stay on stage quickly, and I'd like to welcome Reza to join us. Hello, Reza, and also Emily. Hi.
Hello.
Welcome. So, I'm not sure if you were following Adib because we were on the backstage, probably preparing for your presentation. But what do you think about AI agents doing stuff for us?
It's early days for it. It's a long time coming for those of us who have had an academic interest in AI. We were thinking about dreaming up such things, almost 15 years ago. So it's good to see it finally come to fruition. I think it's still early days. We'll see what the practical applications are and to what extent it actually adds value to the end user.
Thank you, Reza. Emily, what are your thoughts?
I really think agentic AI is kind of going to be the hot topic. It already is in basically 2025. And I will see basically is I'm already imagining when I wake up, my AI agents tell me doing all the stuff for me and create a action item for me. So this is kind of for us, and also for the applications. I think is for the chatbot. And AI agent is going to play an essential role there. I really think that in the future, a lot of applications will be agentic AI applications.
So, the three of you are conference speakers. You travel, you present. Emily, I'll ask you, what is the one agent that you like Adib to build that would help your life as a conference speaker?
Yeah, I tell you what it will be. Plan my kind of the trips and how to get to my hotel room, and which train to take, which public transport, or if not, basically, and then what time to get up and to go to the also can build up my conference days as well. Like I also need to attend some of the, even though I travel at a conference, I probably most of you are as well, also need to do some calls as well, right? I want an AI agent to tell me actually, yeah, this call you must attend, you must do. And then it's kind of also plan some interesting talks, and then arrange some meetings to meet some other friends and also the experts. And I really love the basically meeting people at the conferences, and then broaden my horizon a lot. I think that's where I got a lot of wisdom from.
Adib, is that something you can do vibe coding for an hour?
No, but I can tell you that the one agent I built for speakers, it takes your LinkedIn and makes a bio for you. Because I hate writing bios for myself.
All right.
That's one of my Git demo repos. But that one is more than an hour of coding. I may need an AI agent to help me build a new AI agent.
Absolutely. All right, Adib, thank you so much again. Have a wonderful day.
Bye-bye.
And Emily and Reza, yeah, thanks for joining JDConf, and you're welcome to start your presentation now. Thank you.
All right, so without further ado, let's get rolling. I'm Reza. I'm Principal Program Manager for Java on Azure at Microsoft. In the context of this particular talk, I'm actually the Microsoft representative in the Jakarta EE working group. So what we'll be talking a little bit today about is the possibilities for what's beyond Jakarta EE 11. Obviously, that's Jakarta EE 12, and talking a little bit about what that content may be. Now, bear in mind, one of the key things here is that it's Jakarta EE is a multi-vendor thing. Nobody controls anything. There is no formal roadmap. The roadmap is what we all define. And that is what makes this particular talk even more important, is because we all, including yourself, I hope, will get involved in the process and help us define precisely what Jakarta EE 12 is going to be. But this is just simply some ideas on behalf of myself and Emily, and in fact, the Jakarta EE ambassadors, which I'll talk about in a moment, about what we envision in Jakarta EE 12 and beyond. So I should not neglect to mention that Emily will be, I'll be handing off to my colleague from IBM. Emily, she'll introduce herself. I think that's really the best thing to do. And I'll be sort of handing over to her about halfway mark. So maybe in about 10 minutes or so, I'll be handing off the presentation to her. Won't be making too much ceremony. Hopefully it'll be just a seamless transition from me to her. So thank you very much. I do hope this is going to be worth your time. There's a bunch of things that I've already shared in the chat. Please do take a look at that. One of the key things there that I'd like to mention is that we're rather compacted here, and that's maybe to some extent a good thing, because if you're not really interested in the deep details of what may be coming in Jakarta EE 12, maybe this is the right session for you. However, if you are the kind of person, or maybe become the kind of person as a result of this session, that's interested in learning a little bit more, I've also posted a link to another session we'll be presenting on Friday. That's an hour-long session, and it's just a lot more slow going and a lot more detail that I'll be able to get into. Now, for those of you who haven't been following, you at least know that Jakarta EE is not a spring chicken. It's been around for forever and a day. I've been involved. I've been a user since J2E 1.4. It seems like a lifetime ago now. I've been an active participant in defining Jakarta EE, sometimes literally writing text specifications. Over the years, that's been since the tail end of Java E5 onward, and that also seems like such a lifetime now. But now we're talking about Jakarta E12. Jakarta E11 is almost out the door. The core profile is out the door. The web profile is out the door. I'll be showing you a little bit about how Jakarta E11 looks like. And of course, now we're talking about Jakarta E12, right? Which is so very much, without going into a long-winded explanation of it, I would say the transition from Java EE to Jakarta EE is now a success. I don't think there's much arguing that is in fact the case, and now it's a matter of truly making it a success. Now, the fact that it has been around for so long and really still has an impact, I think, is a statement on its own as to why we need to do this important work, frankly, for everybody in the Java ecosystem, whether they're using a Jakarta EE runtime today or not. So one of the other things I'll be using as an anchor for this particular talk, or at least for my portion, and I believe Emily will do the same thing, is one particular artifact which I have shared in the chat already, and that is the Jakarta EE Ambassadors EE12 Contribution Guide. Now, let me give you a little bit of a context about some of this as well, if you're not aware. So Jakarta EE Ambassadors is something, back when it was called Java EE Guardians, is something that I helped form back in the day for good reasons that continue to remain to some extent. But one of the things we did back in the Jakarta EE8 days is come up with this artifact that I've linked to you today, and basically will be giving a synopsis of. And I'll be honest with you, the real reason we came up with that artifact back then is to make sure that the things that we identified as gaps back then in Java EE8 do not get lost in translation, don't simply get dropped in the transition from Java EE to Jakarta EE. So this is the historical roots of this work, the contributor guide, and to some extent it still remains, right? It remains precisely that. So you can take a look at this document, and it will basically give you a high-level overview of precisely what it is that we're talking about in terms of an active backlog for Jakarta EE as a technology, EE12 being its latest rendition. So we've had a few renditions of the contributor guide now. We've had one for 10, 11, and now 12. So you can actually take a look at what is actually being delivered in the specifications in that context. So this is basically really what this slide is all about. This is really what it's doing and what the color coding actually means. So you can see a list of features that are broken down by high-level themes. I'll be diving into a little bit of details of what these are to the extent that the time will permit. And you can see some things have made it in, some things are on the way, and some things still remain gaps, right? So it's a gamut of various different things that we are talking about. And we saw at schedule come in, or at schedule not make it quite yet, and there's a few things that happened in E11, namely better support for CDI and Jakarta persistence. That was actually a big one. Some support for virtual threads. In-memory data store made it into Jakarta EE security, and then the whole bunch of deprecations and a whole bunch of stuff that's in flight, right? So if you subtract these things from, and of course one of the biggest things is a new specification in Jakarta 11, which is Jakarta data. Now, you can basically deduce what we might envision reasonably as gaps for Jakarta E12 to address by effectively subtracting the things that were delivered and maybe adding a few new things, if you will. So first category of these things are things to make basically EJB unnecessary to use. So all of the things that are locked into EJB today, all of those can be usable in a much more modernized way. We've been doing that a little bit at a time, right? But there's still some things that remain. So some examples are at schedule, lock, max concurrency. I'll be talking about these things in a moment. Message listener in messaging, roles allowed in security. I believe Emily will be covering that to some detail. Again, aligning all of the things in Jakarta EE towards CDI. One example would be getting rid of the add context annotation in Jakarta REST in favor of just using CDI add inject. Java SC alignment, one of the key big ticket items for Jakarta 11 was essentially alignment with Java SC records, right? So that you can use records across the platform. Not all of that work was done. One of the key things that were remaining was actually record support in JSON binding, formally in the specification. Similarly, in order to make things more friendly in Java SE, you need to have things like Bootstrap APIs, and I'll show you an example of that, and you'll understand what I mean. Back then, having more standalone, modernized TCKs, a lot of that work was actually done in E11. Actually, that delayed, that was one of the reasons why E11 was delayed, but there's still some work that remains there. Closing important standardization gaps. One of the key things, in my opinion, is going to be HTTP 3. Right, so making sure that at least the servlet spec is capable of HTTP 3. And there's some other things that hopefully we'll have time to talk about. But if there's not, definitely I'll be covering, in my portion of the talk on Friday if you're interested in that. And of course, deprecation. There's a whole bunch of stuff that we need to continue to deprecate. Hopefully someday even EJB, but certainly the application client container and things like the security, Java SE security manager references across the platform. Some new specifications that have been long-standing gaps, things like configuration, NoSQL, MVC, gRPC. These are all sort of in various degrees of development, right? And all good candidates for bringing into the platform for E12 and beyond. Now, very quickly doing a super fast tour of what we're talking about when we're talking about some of the potential features. So I talked about schedule and at lock. I'll show you a concrete example of those two things, adding max concurrency. I'll show you an example of that when I talk about messaging, and also making sure that CDI actually works well with the Jakarta EE concurrency paradigms. That's yet another potential gap that remains in the platform. Here's an example of the schedule. So this is possible today using EJB, using slightly different, slightly outdated syntax, but you can do it in EJB. Well, why would you, right? You do this in all kinds of CDI beans and not just limited to EJB. So the wish here is to add the equivalent of EJB at schedule in a CDI compatible way. It's somewhat kind of there in E11, but in my opinion, really we could clean up the syntax and make it much more user-friendly in E12. So this is one of the possibilities. At lock annotation, again, there's something hidden under the hoods of EJB, but actually incredibly useful functionality. Right, so whenever you're talking about now using CDI, particularly application scope beans, in a concurrent, highly concurrent application, suddenly you actually can make use of these concurrency semantics. And instead of you having to do that in the bean, you could actually do it in a declarative way. And again, this has been, we've proven this model out for years, right? This has existed in EJB since E6 actually. So again, this is one of those things that we could bring out and make shine in CDI land instead. Jakarta messaging, hugely important one, and I'm running out of time, so I'm really going to hurry up and I'm going to hand it over to Emily just as quickly as possible. Jakarta messaging, hugely important and once incredibly popular API. Hasn't been revisioned, hasn't had a rep for a little while, but a lot of important stuff here, a lot of good stuff here that if we revive this and make it really a modern, polished API, really it could play a very key role in breathing new life into Java messaging in general, and certainly the Jakarta platform itself. The message listener example, I'll show you. You will see that for yourself why that's so interesting. Yet another thing is creating a light version of Jakarta messaging, more suitable to cloud native runtimes, right? So this is a very old API. You can actually take a fresh look at it and create a light version of it that's more suitable to today's messaging, cloud native messaging environments. Having a standalone Bootstrap API, again, code will speak much louder than words, and I'm just going to show you the code in just a moment. Things like interoperability with other standards. AMQP is one of them. MQTT is yet another. So this is another vast, pretty important and interesting area that we could tackle in Jakarta EE messaging. So when I talk about a message listener, this is really what I mean. So today you can kind of sort of do this using message-driven beans, but very antiquated syntax, right? It's very far from modern and certainly only usable in an EJB context. You can much improve and make the syntax a lot nicer. You can kind of see that here, right? So it could be, you could do things like, process messages in batches, order by timestamp or some other characteristic of the metadata. Put in retries, put in retry delays, specify dead letter queues. All of these sort of things are either not available in EJB or very vendor specific, and there's no reason to, right? And you can also do things like For example, concurrency throttling in these kind of environments. This is where something like the max concurrency annotation that would go ultimately in concurrency would come in very handy. This is what I mean by a Bootstrap API, right? Right now, you can't really do this in a vendor-neutral way, but you ought to be able to spin up a JMS instance on its own in a Java SE environment outside of Jakarta EE altogether. This is something we've been talking about since Java EE8, Java EE7 timeframe. So very long pending and important. We know that there's a demand for it. We know there's value to doing this work. So that's about it. From my side, I'm going to now hand it over to Emily for the rest of the session. Stick around, please. And again, if you want any deeper dive into this, join me on Friday.
Okay, great. Thank you, Reza. So thank you all. And I'm Emily Jiang. I'm over for IBM. I'm a Java champion, and I'm also a cloud native architect. Has been working on Jakarta EE and microprofile.
Emily,
yes.
I'm so sorry to interrupt you. You are sharing your presenter view, so.
Oh, sorry.
All good. Just want to make. There we go. Perfect.
And basically, it's also work on the implementations on OpenAI. So it's great. I mean, Jakarta EE has been making great progress, recently, since the Jakarta EE 9.1. And if you have not basically tried out Jakarta EE 10, and also the other great news is we just released Jakarta EE 11 web profile this week. Please check it out. And for the carry on with the Jakarta EE 12 is very exciting stuff. Reza already mentioned. I will quickly talk about the rest of the slides. So Jakarta security. If you have heard of microprofile, in microprofile there's integration spec is a microprofile GWT bridge. So basically make the Jakarta security work with GWT technologies. And also in microprofile GWT, you can use the roles allowed. Hopefully we also add this roles allowed to Jakarta security as well. And the other thing is kind of Yale-enabled authorization annotation. As you know, people don't really want to use XML to do all the authorization, also role defined, basically have the role allowed and etc. It's great, like your Java applications, you can see, crystal clear, like authorized, has role manager and scheduled office hour, and then you can do the transfer funds. So this is very easy, crystal clear to read the code. And similarly, for the other method, get salary, as a role is manager, and also has an attribute directly reports, and also with the employee ID, and you can get the salary. The other thing is kind of the configuration has been talked about for many years. I can see that since the Java EE years, I'm trying to do the configuration, eventually didn't make it. And in microprofile, this is the first spec ever in microprofile. I'm very proud I was part of it. And we define great basically programming model in microprofile. It's called a microprofile config. If you have not watched the discussion recently, like the proposal put forward about host microprofile in Jakarta EE, is one of the major trigger is because Jakarta need a config, and it's great to move microprofile config over to Jakarta. And since that move, it makes more sense, for the two community kind of merge together. So this is kind of Jakarta config. I'm really excited. Hopefully in EE 12, we can basically get a microprofile config in the core profile. And then the Jakarta config will have basically the programmatic lookup and also CDI injection. You can, in this code snippet here, you can inject the maintenance basically it's a property into your application. And then you can define the maintenance property in basically in the system variable or environmental variable or system property or any files. In this case, the meta-inf microprofile-configured properties. Maybe it will call just configured properties when it move over to Jakarta land. So this is a kind of the very flexible basically configuration, so that basically your application can easily to be configured. So there's many others kind of the features we want to add, like basically in the Java, latest Java, and we will have basically the 21, you have a record and virtual thread. As you can see, the E11 already make use of record and virtual thread, but not every basically spec. And then in E12, it would be great to make the support in JSON binding, and also the in CDI. Basically, we are trying to make a CDI to replace EJB, CDI plus concurrency to replace EJB, but EJB has a startup. And then it's people talking about, yeah, in CDI already got a startup, basically, or you can observe the startup, this event. However, it's not easily to be used. It would be great to introduce basically annotation at eager, similar to EJB at startup. And also batch job, and then is if you know the batch, and then you have to define your job in another file. It will be excellent, and to put the batch job definition basically in the Java classes. And the other thing is basically again I mentioned the CDI plus concurrency, trying to replace the EJB. The other great annotation, the functionality from EJB is basically stateless. Stateless is not same as basically dependent scope to CDI bin. Stateless is as a transaction associated. So it's so this is built-in at service in CDS steering type. So basically, we'll have a transaction associated with, and plus other scopes and etc. So this is basically trying to get up to offer equivalent EJB functionalities. And also is kind of in the Jakarta persistent, and utilize basically improve the persistence.xml. And also the Jakarta EE would be great to have the Bootstrap APIs. So in the next few slides, I will quickly go through. So this is example, the records support in the JSON binding. So here you can define the record, and eventually you have a basically list of this record. So this is another example, define the jobs with this kind of Fluent APIs to directly build the jobs. So I think the batch users will welcome this feature. A similar thing, this is a service, so has a scope, application scope, the transaction, and then concurrency specified. And then this is basically Bootstrap API for Jakarta EE. So this is kind of no longer you need to have a lot of ceremony to be able to create a Jakarta application. Now it's just like everything's from main. It's similar to the Spring apps. So this is finally we are in the AI era, and if you are wondering about Jakarta EE microprofile AI, story. So it's we are having basically microprofile Jakarta EE AI discussion, and we have decided to adopt a long-term 4J. And right now there's a GitHub repo and a long-term 4J-microprofile-Jakarta. So we are going to populate this repo as we speak. So we have meetings every week. Please feel free to log on to the microprofile calendar if you Google that, and then find out the time, and then join the discussion. So it will be great to have you around. And earlier, Bruno asked about agentic AI. I really think agentic AI support is very fundamental for this. Basically, the microprint Jakarta EE AI apps. So with that, I think it's this is a way of contributing to Jakarta EE, and would love to see you in the Jakarta community. So stay tuned and to see the progress on the EE 12. So with that, I think we are towards the end of this topic.
Awesome. Thank you so much, Emily. Thank you so much, Reza. Jakarta EE has been around. Technically, the brand itself is not as old as Java EE, but the whole ecosystem of these standards is huge, and it is thanks to the work like yourselves and others that contribute to these standards and allow other frameworks to build on top of it. I saw this comment on Reddit. Somebody was like, "You know what? I wanna rewrite the servlet API or something like that, because I think the servlet API is too rough." And I think it is, but it has to be, so that other stuff can improve on top of it, and then other stuff can build on top of it. That's how the ecosystem works. If you come up with an API that is just like, this is it, then how do you build on top of that? How do you allow that ecosystem? Jakarta EE allows with technology like Quarkus, technology like File, and other frameworks that build on top of these APIs. I'd like to welcome to stage Mark Hackler, our next speaker, who has been advocating for Spring for many years. And it's interesting because Spring builds on top of some of the Jakarta EE APIs as well. So, Mark, are you around?
Hey, everyone.
All right. So we got Mark Hackler here. Mark, do you remember the first time that you wrote your first servlet?
No. It's been long enough ago. I probably don't remember that far back.
It's good that we don't have to write services anymore, but the importance of that particular specification is huge for the world of Java web applications. Whether it's web application per se, whether it's a REST API, all of these things are built on top of the servlet API. Mark, what is the one thing that you feel like Jakarta EE could add to its specification in the coming future?
Oh, that's tough. I mean, obviously everybody's wanting to do AI, and that's very important. But I mean, it's already being incorporated in various different ways in pretty much everything. So I don't think that's any new revolutionary idea. But I think you're gonna see that natively supported in pretty much everything, including Jakarta EE. I have to tell you, I was really concerned that after asking about servlets, you were going to ask about applets, but I'm glad you didn't go there.
Anybody here ever wrote an applet?
Yes, plenty. Yeah, also writing my first servlet as well. But I think for Mark, HTTP3 may be the thing that would be of interest to Spring developers in general.
Yeah, I'll take it. And
Mark,
I refuse to answer on the applet question on the grounds that it may incriminate me. Yes, Emily.
You got to try the Jakarta data.
I
Spring data. I would like to know your feedback.
Yeah, I mean, I'm game to try anything. In fact, I think I was kvetching to Bruno about this a little bit yesterday. My big problem, probably all of us, our big problem is just time. There are so many things. I keep adding things to my list. It's like, when I get a few minutes, I want to try to work on that. And when I get like half a day, I'll explore that. And my list keeps growing. And I do remove things from the list. I get through them, but it seems like it grows faster than I remove. So the queue grows. But yes, I'll add that to my list. Yeah.
You need the AI agent.
I use AI agents actually, but the problem is that after a point, I mean, you still have to learn it to understand it. So the agent can do a lot for you, but it can't learn for you. It can just learn for itself. So, so to speak.
Yeah, agents are fascinating, but I feel like we are going from code reviewers to AI output reviewers. At the end of the day, like we as developers always want to, like, I want to review less code, especially other people's code, and I like to contribute, but it's kind of boring reviewing all this code. But now with AI writing code for us, everyone is becoming a reviewer. Everyone is reviewing code every day. That has become the standard now.
Well, there was some kind of a cartoon that somebody had drawn about, using AI to craft your email, and then on the other end, somebody uses AI to summarize the email that AI wrote on behalf of someone else, and yeah, so it's interesting where things are going, but in most ways good, but occasionally something that just is kind of hilarious. So
I think we're getting to a point where we're gonna have to say this was not generated by AI and have a certified stamp on it.
Yes.
We would just assume that everything got generated by AI, whether it's code, documentation, emails, presentations, it doesn't really matter. We'll just assume everything is AI. We'll need a stamp saying this was not generated by AI.
Probably safer, yeah.
All right. Reza, thank you so much for your presentation. Emily, thank you so much for joining us as well.
Good to see you both again.
Day.
Yeah, good to see you. Bye.
Welcome, Mark. Stage is yours, man.
Oh, hey, thank you very much. Okay, let me go ahead and share my prezo again. Share entire screen. Hopefully this will work. There it is. Okay, great. I love it when things work. Speaking of which, today, boy, this is just going to be a fast-paced presentation because I'm told I only have 3 hours. That's right, Bruno, right? Okay. Just kidding. So I took a far-ranging talk and I've scaled it down, but I feel like the essential elements. So if I miss something, if I don't expand on something as much as you might like, by all means, please let me know. I probably agree, and I'd be happy to talk about additional things offline. But we're going to talk today about production best practices, or how to go from dev to delivered and stay there, kind of my Lord of the Rings-esque title there. My name is Mark Heckler. I'm a principal cloud advocate of Java and JVM languages with Microsoft. I will have questions and answer time, I hope at the end, at least a few minutes. If you can't get your question answered within that time, or if you think of something later after the fact, which is what I usually do, please do reach out to me. I'm on all the socials as far as and most of them center around MKHack. So on X, I'm MKHack. On Mastodon, I'm MKHack at mastodon.cloud. I'm on Blue Sky under MKHack. The only exception is Mark. But other than that, I'm here. If you must reach out to me by email, obviously I'm on email, but you'll get a fast response typically on the socials. So with that, let me close out this little or hide this little message so it doesn't take over the screen there. And then we're off and running. A bit about me. I am an architect and developer by background. I am an advocate. That just means that I like to combine, or I get to combine, two of my favorite things in the world, coding and talking about it. I'm an author. If you're interested in the latest book I've written, it has an X, Twitter, whatever handle as well. Follow it there. I'm a Java champion, an AI Jedi, and a licensed instrument-rated pilot. That last one, by the way, is the US FAA issued. The AI Jedi role, I still haven't received my certificate for. I don't know who I need to reach out to about that, but I'm sure it's in the mail, right? So a quick overview. We have a lot to cover in roughly 30 minutes together. We'll start by examining application best practices, focusing primarily on Spring Boot Java applications, but most of these principles do apply more broadly. It's just that many of them are specific to Spring Boot and Java. That's where I live most of my time, and that's where what I'll use for my examples. Then we'll move to infrastructure as code with a few different options you might choose to use. And then we'll talk about CI/CD, continuous integration, continuous delivery pipelines. I use GitHub Actions as a great example. Obviously, most of us park our code out on GitHub, either private or public repositories, and GitHub Actions. GitHub is a platform, right? So you might as well make full use of it since you have access to it. It's a great example. It shows some really great capabilities that are of great utility for all of us, right? We'll talk about monitoring and observability. And finally, we'll discuss some patching and security practices as well. So let's start with the application best practices. We need configuration of the app, of course, version control, build tracking, etc., and then externalize that configuration so it's versionable, it's versioned and refreshable, so that you can have better capabilities when you do cloud deployments in terms of refreshing different things live. You also can externalize that so that if you have any issues, you don't have to tear everything down and redeploy. You just basically update a configuration and refresh that as well. Actuator is the foundation upon which a lot of things are built, really. Even of that build information that I mentioned, using something like Get Commit ID Maven plugin or a similar plugin for Gradle, so that when you have your application deployed, you can point with that application information back to the build, the very code that it was used to build that particular release of that application. Actuator allows you to secure and only expose the specific information you want with the scope that you want. So you need to, there's a lot of great information, useful information that Actuator can expose, most of which you don't want to be exposed to the world in general, but is very useful for developers and operations types folks to get in and isolate and identify and resolve potential issues or troubleshoot things as need be. There are three pillars of observability, say that 3 times fast. Three pillars of observability, logging, metrics, and traces. And those are also actually handled by Actuator and various extensions, additional libraries, and or configuration settings. Actuator provides dependency management and auto configuration for Micrometer, which is a facade supporting a wide variety of monitoring systems. You have things like micrometer metrics, micrometer tracing, and Actuator provides the foundation upon which all of that builds. And then, of course, in your application, you need error handling and resilience. Error handling because you need to properly address things that, again, can go wrong and often, well, hopefully not often, but occasionally do. And then you need to have a very resilient app, build in things like circuit breakers or retry and retries with backoff. Typically, a clean degradation is usually better than an abrupt failure, depends on your circumstances, but of course, that gives you flexibility, and it's always good to have options. So containerization is a crucial aspect of modern deployments, right? So we start with base images. We build a container around that, or container image, I should say, around that. And then we look at ways to isolate our runtime versus build dependencies. We'll talk a little bit about multi-stage Docker files and when they come into play, and then we'll discuss some image security considerations as well. And I know I'm going kind of quickly on this. I don't want to gloss over anything again, but what I want to do is start a conversation about these things, cover the high points, and drill in a little bit into certain areas, but certainly set the stage for us to have this ongoing conversation as we go. But I wanted to give the most information, maximize our coverage here. So as developers, we typically start when we approach containerization, because containerization is typically apps. So how do we get started with that? As a new developer, I guess, to this part of the life cycle, we'll typically start with a Docker file. And we'll go to the Docker documentation, we'll read up, we'll see the sample Docker files, we'll grab one of those. We'll use a full-size operating system. We'll drop Java and our app in there. We'll expose whatever ports we need to, and we'll define what the initialization application, the command to run upon initialization for a container based on that image is. And when it comes to containerization, I'm probably repeating something that most people know, but there are a few, right? Everybody's new to something at any given point in time. But when you talk about containerization, you create an image, and from that image, numerous different containers can be created that are identical, right? So your image in many ways is your template from which your containers are built. So this works. And if you're kind of doing a proof of concept, pulling in that full-size OS, Java, your app, boom, you're off and running, and that's enough. But if you're doing this for very long, if you're working for a big company, if you're taking things from proof of concept to actual production, most of the time you look for ways to make things better, make things leaner. I'm going to say something that isn't 100% correlation, but it is a high level of correlation. Leaner is better. A smaller container image size typically parallels a tighter and a faster startup. It's faster to build. It's faster to deploy the containers from those images. requires less storage, less memory, etc. That is a very broad brush approach to that, but you see a lot of correlation there. It's not 100%, but it's a high degree of correlation. The smaller the image, typically the better off you are, and again, very generally speaking. But what we want to do, and what we typically do, is evolve from a smaller or to a smaller base image in Java JDK input, right? And distroless offers the leanest base image. Now, distroless is like serverless. There's no server, there's no distro. Kidding. Distroless doesn't mean that there's no Linux distribution under there. Typically, what it means is you've pulled out every bit of non-essential stuff that you don't need to run your Java application. It is as close to 100% fit for purpose underlying OS as you can get. And I'm using an example here for our JDK 21 distroless base image. I'm pulling that from the Microsoft Container Registry. And the rest of it looks very similar, right? We're copying our jar, our pre-built jar that we've already created, typically on our local file system, to our container image. We're exposing a port. In this case, we don't have the Java command there because it's baked into our distroless build, but everything else is very much the same. And that makes a smaller image. Now, then we look at things like containerization or multi-stage containers, container images, builds. So multi-stage builds allow you to use a full featured base image for the first stage to build your app, jar or native binary, although in this case, typically, I'm going to show you just 100% jar files. And then we use a lean base image for that second stage, with or without the JDK as JVM versus native. But again, this is more applicable in this case, and 100% in my example here, to a JVM build. Because that way we can have the full OS, we can have our build tools like Gradle and Maven, we can do everything else that we want to do, need to do, we can pull in security or scanning tools, and we can build our jar file. And then the only thing we extract from that larger container image is the jar. That's it. And then we put that in as lean an image as we can down below. We create that, and that resultant image is much smaller, much tighter. It has a reduced attack surface because, again, there are no extra threads to pull, figuratively speaking. I'm not talking about CPU threads, but all superfluous utilities, config files, everything else that you don't need to run that app is absent, and you can't compromise what isn't there. There is more to consider about security, but we'll talk about that more in the next few slides. So everything that I've talked about so far is kind of the way that most people get started in terms of building container images for their applications. If you're a Spring Boot developer, you can actually use the Maven plugin or the Gradle plugin and do something like Maven W Spring Boot build image or Gradle W boot build image. And that kicks off a lot of built-in capabilities that you can use and put to good use for you. So this uses cloud native build packs, and there are build packs available for a lot of different languages. But of course, all we care about here is Java right now, and Spring Boot Java apps in particular for the moment. So what that does is it uses a cloud native build pack to instruct it how to create that image. It pulls in a very lean base image, and then it also has certain pre-configuration settings. So it will has a predefined set of layers from the least changed things to the most changed things, the most changed being, of course, your application code, potentially. And those layers work pretty well. The predefined settings work pretty well in the cloud native build packs. So just by running this, it will create an output container image, an OCI container image. So the Open Container Initiative, we typically just shorthand call them Docker images, but it's an OCI compliant image. Can run in anywhere you have a container engine. So that works really well. I would advise you, if you do this, to start with the defaults and only tweak if you need be, because you may want to tweak the layers.idx. You may want to change the layer definitions. Probably not, but you can. If you have a particular JDK that's supported by someone that your company contracts with for that support, if you have just a recommendation or a group guidance or whatever to use a particular JDK, you can swap that out. But again, you start from the defaults and build out from there, and that works very, very well as well. Now, let's talk a little bit about infrastructure as code, because so far we've talked about building that application and that container around that application, or container image that will create those containers that contain that application. But we need to obviously have a place to deploy that as well and to build out our supporting services. So assuming we're going to deploy that to Azure, we'll need something like an Azure Container Apps environment, an Azure Container Apps app instance, the construct into which you deploy that app, that container. And then we'll need things, any supporting services like database services or messaging platforms or anything like that. So we need some way to do that in a repeatable fashion. And infrastructure as code gives us consistency. We can version control our infrastructure. We can, it has repeatability because you can literally pull the same scripts and run those and have the exact same outputs every time. You do have options for doing this. I mentioned a lot of times the ARM, the Azure Resource Manager, and ARM supports things like ARM templates, or you have ARM templates and you have Bicep, both of which are used with the Azure CLI, the command line interface, which is great. You also have other options, third-party options like Terraform, OpenTofu, Pulumi, other great options as well. We'll discuss those as we go along. State management strategies include how to handle different environments like dev, staging, production, etc. Different deployment targets may require different supporting services when you're going from dev to prod, for instance. You may have different databases underlying that or whatnot in different deployment scenarios and other things like that. So the basic high-level principles for infrastructure as code, you want to store your infrastructure as code files in version control systems so you have the entire history of your infrastructure. So you can track changes, you can debug issues, you can revert to previously known good versions if you have any issues. Pardon me. Infrastructure as code ensures that infrastructure configurations are consistent across different environments because you represent the entire desired state of your environments via code. And by doing so, teams avoid errors due to manual configuration. It also enforces uniformity. Everything is 100% consistent when you pull from the same, drink from the same well, if you will. IAC acts as documentation, so you can kind of get that background and you can understand how things are being created and what's being created. It provides automated testing and validation because any changes go through full pull requests. You can have code reviews, static analysis, and transformations before you deploy it, even for the first time. So that elevates the quality of your infrastructure as code. And then finally, there's item potency, which means that you can execute this repeatedly and produce the exact same result. So just a few examples here really quickly. We have our infrastructure as code. I'm using in this example ARM templates. ARM templates, as I mentioned, use the Azure CLI, which is up to date with each release of each platform target, which is pretty awesome. So if a new version of Azure Container Apps rolls out or AKS, you know that AZ CLI is going to be up to date and you're going to be off to the races as soon as the new features, the new APIs drop. Boom, you're completely up to date. ARM templates use JSON, which is ironically enough somewhat space consuming. I've collapsed a lot of these sections here because it just goes on and on and on and space consuming, but it is when you compare it to something like Bicep. Bicep is much tighter. It's much neater. It's easier to read, in my opinion. Your mileage may vary, but it's more declarative. It is still JSON-esque, but it's much more declarative in my mind and not quite as space consuming. So taking it from there, we go to something like Terraform. And Terraform, I'm using Terraform as an example, but there are many other similar offerings throughout the industry that kind of parallel this type of implementation. Again, you have to choose a few things to show, and this is just what I chose here. Terraform uses a fully declarative syntax, again, and the Terraform utilities to execute on these, which all that's pretty easy to work with, and the format is nice and compact, really. One big downside to using a third-party option like this, like Terraform, OpenTofu, Pulumi, and pretty much is that with each API, case, let's say the Azure Container Apps API, but it could be like the Azure Cosmos DB API. But with each update for any platform offering, whether it's a destination, a service, whatever, there's a delay between the releases of the new platform API and its full support in that external, that third-party infrastructure as code toolchain and its templates. It just takes a little while for them to implement it, test, and deploy it so that the rest of us, the entire community, can use it, which is good. You don't want them to release stuff that isn't tested, right? That's a bad thing. But there is a delay. There is a necessary lag there. So that's a bit of a downside. Again, that's balanced against everything else. A lot of times people, and I've done the same thing over the years, look at a third-party option and say, well, that gives me a lot more independence because I don't want to be tied in, locked in, if you will. Not true, as I just mentioned, but I'll take that a little bit further, because while Terraform in this example is independent of Azure, the actual resources and resource definition and syntax varies between, let's say, Azure and another cloud provider. If you notice, you have Azure RM, which stands for Azure Resource Manager, container app environment, and you have certain fields or variables that apply to that. You have the Azure RM container app, and then you have other Azure Resource Manager type of segments, sections that apply. And those don't apply to other cloud providers, for instance. So even with a third-party option for infrastructure as code, you're still very much cloud specific. So I don't see that as a huge advantage over something like the ARM templates or Bicep, but it is something to consider. You have that delay. You're still somewhat tied in, but of course your tools knowledge does apply across platform as well. So again, whatever you use, just use something to get that infrastructure as code versus having to manually configure and introduce variations and potential errors along the way. So, pardon me. So with each, once you have your infrastructure as code defined, you've got the ability to build out that infrastructure. You have the ability to build your app, test your app, containerize your app. Now, how do you get it to production, to those targets? So you have something like a CI/CD pipeline. GitHub Actions is a great example of that. And with GitHub Actions, you have the ability to define workflows and to create resources to build your app, test your app, deploy your app, even use things like blue-green deployments so you can make sure that you do an orderly cutover in production based on different triggers that you define. Different branch PRs or commits, you kick off different workflows. Secrets are managed using GitHub or Azure Key Vault or other supported external secure mechanism. Unauthorized users never get to peep your keys, which is the important part. You have these tools interacting with each other securely, and you greatly reduce or eliminate any chance of secret leakage, which is super important. We don't want even the smallest secret to escape in the smallest scope, because that's a good way to become a headline, and no one wants to become a headline, not for those reasons. So just an example, your mileage may vary, but to use GitHub Actions, you have to, within some project, define a .github/workflows directory and populate that with various applicable workflows defined in your favorite format and mine and Bruno's YAML. Anyway, once you've created these using the applicable component actions like checkout code, setup Java, etc., you define the triggers that cause each one to run. And as you can see in this example, we have a small number of workflows that cover a lot of ground and that are triggered by a number of different things and at varying frequencies. For instance, the build workflow runs on every pull request and every push to main. The deploy to dev environment runs on push to main. The deploy to production workflow runs manually or on a particular release level. And then you have a security scan, which actually should be run on a scheduled basis, but also allow for you to execute that on demand at any time you feel like you need to do that. So in my example here, I only have 4, but they cover quite a lot of ground, and you're certainly not limited to what workflows you define. This is an example of secrets being handled within GitHub itself or by GitHub. You define the secrets your workflows require, provide the values, and use those variables in your workflows. Only in the appropriate workflows, of course. You don't want to expose all variables to all workflows. It's just not needed. And again, you don't want to add to your exposure. Secrets can also be managed by external secure mechanisms, like I mentioned, such as Azure Key Vault. This allows you to centralize key storage and administration in one place, Azure, eliminate redundancy, potential mistakes, and reduce your attack surfaces. Again, unauthorized users never get a hold of your keys. So some examples of my actions as I have here, and these are just small excerpts of some actions. They're actually much larger and can be very, very large depending on what you want or need to do. We have a build and test workflow, a deploy to development, and a deploy to prod workflow. And by the way, those two deploy to workflows call a common reusable deployment workflow that actually, based on flag set, will deploy to production or deploy to development. So you can reduce the code reuse or increase reuse, but you reduce the duplication of code, which of course is always a good thing as well. So you keep consistency and you don't let things potentially get out of sync inadvertently. So for that build and test workflow, you have an app build and a container image build. Of course, again, we do it all, right? During each workflow, it should all be tested in every way that's meaningful to maintaining quality and security throughout. So for instance, in the app dependencies scan or part of the workflow, what I do is I'm employing plugin to check the workflow, the application dependencies, excuse me, and Trivy to scan the container image built by the build and test workflow. Later, we'll explore the code quality checks and some ways to do that as well. But this just gives you an idea that we want to bake in security at every level throughout that pipeline, right? Just some high-level best practices for GitHub Actions workflows. Always use the exact versions for the actions you use, something like action/checkout at v4 instead of the action/checkout at main. You want to use a specific version number and then cut over within that workflow when it makes sense for you to do so, when you can test that and do that properly. Only use secrets in the jobs that actually need them. That probably should go without saying, but again, it's a good habit because we all get busy and we sometimes overlook things and we just dump things in that maybe we don't need. That's not a good practice. Add timeout minutes parameters to jobs to prevent workflows from running indefinitely. That's always a good practice so you don't have an out of control workflow that just keeps running for no good reason. Add the concurrency parameter to cancel in-progress workflows when new ones are triggered. This also makes perfect sense. So you can stop something that really doesn't need to happen when you kick off another workflow. Create reusable workflows. And I showed you a very small example of that, but you should extract common functionality into reusable workflows to avoid duplication. Add thorough testing in the build workflow to catch issues early, and implement caching for dependencies to speed up those workflows. You should also finally configure notifications for workflow failures to appropriate channels because you want to know ASAP when a build doesn't complete successfully, when a workflow doesn't complete. All of these capabilities, the monitoring capabilities, should be created when creating and deploying the applications or systems infrastructure. Bolting on these things after the fact is an anti-pattern, just the same as bolting security on after the fact is an anti-pattern. It doesn't help you. In fact, it hurts you in the long run. Short run, essential for applications. And Azure Monitor and application custom in order to define monitor business and app specific details that are important to you within this context, and defining a log logs for each. Now, here are some screens from a typical Azure. I guess I'm off.
All right, so Mark,
Oh, no.
it seems like we are having some issues with the internet connection on your end, and we are also at time. So
Yeah, can you?
Is there any message you'd like
no.
to wrap up with?
Can you hear me now?
Yeah.
Okay, well, yeah, I guess let me see if I can flip through this. Yeah, key takeaways. Those are the key takeaways. So just automate everything, monitor what matters, secure everything, plan for failures, and improve constantly, continuously. And that's it. I would just point folks to the resources there at aka.ms/JavaLearn. We have a few out there. We're adding to those over time. So check them out, free resources. And thanks for coming.
All right, thanks, Mark. Just but hang over there for a little while. I'd
Sure.
like to welcome on stage Yikang Zhang and Rich from IBM.
Hello.
Hello.
Hey, folks, how are you?
Good.
Good, good. Nice
So,
to meet you all.
You guys are going to talk about performance, and I have a comment here, Mark. I think if we want performance, we cannot have security. It slows things down. Is that correct?
Well, I mean, there has to be a balance, because if you have no security, then you have no performance, because you're constantly being hit with DDoS and everything else. So, I mean, it's a balance, right? You have to have both.
All about balance, which is interesting because Rich and Chunk will exactly talk about balance. You know, they're going to show different options, and for each option, what are the pros and cons, so that developers can find a sweet spot to meet their needs based on what they have as goals. So, Mark, thank you so much for your presentation, and have a wonderful day.
Thanks. Good to be here.
All right, so Rich and John, so you're going to talk about InstantOn, CRaC, and native image. I mean,
Yes.
I know about CRaC, I know about native image. Can you give me like a 30-second pitch for InstantOn?
InstantOn is essentially what CRaC does. So the concept is to close down and restart processes. So it takes a snapshot of the image as it's already started, so that eventually what happens when you actually start that image, it starts really, really quick. So the concept is similar to CRaC, but it's just a little different methodology.
Okay. And all the security remains there.
Yes, and we'll find out more.
All right, awesome. All right, I'll leave you two on the stage now. Thank you so much.
Thank you. All right. We're glad to be here and to be at JDConf here. And as Bruno was saying, we'll take a look at some of the latest cloud-native Java innovations, especially when it comes to fast startup, and then that's in the performance domain, right? So we'll take a look at InstantOn, CRaC, and native image today. And Rich and I are both from IBM. We work on what IBM offers in the Java space, right? OpenAI being one of them, and related Java-related projects. So we're excited to be here. And as we know, Java is 30 years old today. Well, not today, but this year. It's 30 plus now, to be exact. And Java's been critical to many different mission-critical workloads and to our industry, right? So it's the foundation for enterprise applications in all sorts of ways, right? Big or small. And as we can see in the last few years, especially, Java has continued to evolve, and a lot of innovations has come to the surface or have been brought to market, right, to make it easier for us to use Java for the next generation of workloads and innovations, right, whether it's for cloud or even for AI and things like that, right? So yeah, and today we'll take a look at some of the cloud-related or cloud-native innovations, right? So and when we talk about cloud, so typically you would think about, so for instance, you don't need to manage as much infrastructure. You leverage a cloud platform to give you what you need to gain flexibility, scalability, and agility, right? Speed to do more with less, hopefully, and also to take advantage of what cloud will offer you, right? When it comes to performance, for instance, security, and cost, right? That's what we think about when we talk about cloud, and what does that mean when it comes to Java, right? And that's what we'll dive into today in the upcoming 30 minutes or so.
All right, I'll take over real quick. So if you're starting down this modernization path, this is considered the heavy lifting part, where we're taking a Java monolith application and moving to cloud-native architectures like microservices and serverless. And if you do that, you're going to run into some issues that are very specific to Java. So namely, Java was never intended to run in these types of environments. So typically running in constrained environments like containers, where you're going to need to be able to start instantly and shut down instantly to have effective scaling as your demand goes up and down. So at the heart of the issue is the Java virtual machine and the just-in-time compiler, which I'm sure you're all aware of. So as we all know, the JVM is what executes our Java applications. Initially, this is done by interpreting the Java code byte by byte, which is relatively slow. At the same time, the JVM uses these profilers to go out and take a look at your running code to determine hot methods or methods that are repeatedly called, and then compiles them on the fly. So This running compiled code is 10 times faster than interpreted code. So the real problem is how long and expensive those compiles are. So here's a chart. Let me see if I can get my little pointer. So on the left, we have CPU consumption. As you can see, tremendous spikes at the beginning. These are all associated with JIT compiles. And then also with the memory footprint, we have some big jumps as it needs more and more memory to compile that code. So here, when your Java application is ready, we're going to use the term startup time. That's when it's ready to receive requests. And then we have ramp up time, which is the time it takes to actually optimize your code to run more effectively until we get to steady state. So let's go over the good and the bad. So the good. So what makes Java so popular, at least beginning, was it's device independent. You write it once, you run anywhere. You only change the JVM, you don't change your Java code. So it's been around a long time. It's constantly being improved. It uses a JIT, as I just mentioned, to really optimize your machine code, much more than you can get with doing a static or ahead of time compile. It has great garbage collection. And because the JVM continues to profile and the JIT continues to compile, your Java apps actually run better the longer they run. So there are some trade-offs. So before that JIT is invoked, that code is interpreted, which is relatively slow. When the JIT is invoked, it can cause CPU and memory spikes, which we saw in those graphs. Those CPU spikes, at the very least, can lower the quality of service. Memory spikes cause out-of-memory issues. So both the CPU and memory spikes slow down startup time and ramp-up time. As I mentioned earlier, let's go on. So if we had a Java wish list for running cloud native, we obviously want to lower costs. That's the whole purpose behind doing this. We want to use less resources, really charge for what we use. So we need to use as little memory and CPU as possible. In order to be effective in that environment, we need to have fast ramp up and startup times. We need to have high application throughput, and we need to be efficient when scaling up and down, including from zero. So that's the bad news. The good news is that there's the Java community is well aware of these issues, and it's where all the exciting innovation is happening. Lots of companies are spending a lot of capital to get Java workloads to work in this space. So that brings us to a couple of, or three, open source solutions we're going to talk about today. So we have OpenJDK CRaC, we have Liberty InstantOn, and we have GraalVM native image. The first two deal with startup time, and the native image also reduces container sizes. So both CRaC and InstantOn are based on the Linux CRaU feature, which is a checkpoint restore in user space. And the concept is similar to closing and opening your laptop, right? You shut down, and when you open back up, everything comes back to where it was. That's the concept. Let's talk about CRaC first, which is coordinated restore at checkpoint. So this was initiated by Azure back in 2023, so it's relatively new. It's now an OpenJDK project that is essentially a set of APIs to access that underlying CRaU technology. So in order to use CRaC, you need to identify and register some resources, which are sent notifications before and after checkpoint and restores. So resources are things like file handles, network connectors, and streaming objects. So objects that need to be opened and closed. They need to be closed before taking a checkpoint and then reopened after a restore. So here's a really small code snippet where, I don't know if my pointer's still working. Yeah. Okay, so I have this, the CRaC library imported. I'm registering this class as a CRaC resource, and then I'm going to write what needs to be done before checkpoint and after restore. So CRaC has current runtime support in frameworks Spring Boot, Micronaut, Quarkus, and Liberty. CRaC is a Linux-only solution, which shouldn't be a problem because this is meant to be run in containers. So I'm taking a look at one example is Micronaut, which is a really good website if you want to learn more about this. It's got very good documentation and has some starter apps. It supports Java 17, JDK 17 or later. It's polyglot with Java, Groovy, Kotlin support, and it has the typical Java dev support with Maven, Gradle, JUnit, etc. So I don't have time to go into a demo, but I did do one. I ran their starter app running both in normal mode and in checkpoint restore mode or CRaC mode. So as you can see, normally this application, it's a starter app, takes almost 7 seconds to start up. But after applying the CRaC libraries, I got it down to 500 milliseconds, which is really excellent. So next, we're going to be talking about Liberty InstantOn, and I'll hand to YK.
Right. So when it comes to InstantOn, it's a full stack solution. So it's a solution that's all the way through from your JVM and your JDK and including your cloud native Java framework all working together to give you that fast startup solution to what you need for cloud native deployments, right? So it's a full stack solution. And then obviously that's built on Liberty and IBM Semruel runtimes. And if we look at Liberty, right, Liberty is essentially a lightweight and a flexible cloud native Java framework, right? It's open source. You can find out more at openliberty.io, and there are resources there for you not only to learn about Liberty, but also cloud native Java topics. And to go with Liberty, obviously there is the IBM built-off OpenJDK from IBM essentially. So that's Semruel runtimes, and Semruel runtimes is OpenJDK distribution that's built upon with Eclipse OpenJ9 as the JVM, right? So it's highly optimized for different platforms, including innovations for cloud deployments in the recent years, right? So. And if you want to learn more about OpenJDK distributions, including Semruel, you can take a look at this article that Rich nicely wrote, and you can find out more there. And when it comes to InstantOn, right, so we'll spend a minute or two on this one. So it's a full stack solution, and it gives you very fast startup and near native startup, and you'll see that in action in a bit. And then it's, as Rich mentioned, it's based on the CRaC technology, right? So you do a checkpoint and restore, right? But at the same time, as we know, JVM is still there. So you have all the benefits of the JVM without losing anything there, right? So you still have, if you need to JIT compilation to speed up, to improve your throughput at steady state, that it's still there. And so not only you have fast startup, there is the benefits with the JVM, and because it's a full stack solution, the focus here is to make it as easy as possible for developers and the technical teams to not have to worry about what they need to do before they can adopt the technology. So because Liberty built the support into, for instance, microprofile APIs and Jakarta EE APIs and all the different APIs that Liberty support. So then as a developer or as a user, from an end user standpoint, right, when you write your application, you need to worry about what your application has. If your application is largely speaking, you don't have to worry about what you need to bring up at startup. You can just easily, very quickly, you'll see in a bit, to create a checkpoint and then restore, and off you go. So the idea here is not only to give you all these benefits that you're looking for to achieve a very fast startup, but also to minimize the work that the development team may have to worry about to get that behavior and performance right. So yeah, that's in a nutshell, quickly, what InstantOn is about, and we'll see that in action now.
All right, let me let's stop this real quick. I apologize. The transitions always are painful. Okay. Can you see my screen?
Yes.
To make sure I'm still connected. Okay. So this is the only demo we have time to show. So this one's on InstantOn. First thing I'm going to do is show that I've created 2 Docker files, one to run with InstantOn and one to run without. And if I do a diff between the Docker files, I know I got it here somewhere, you'll see that the only difference is for the InstantOn is we run an additional checkpoint called after app startup. So that's telling it where to take the checkpoint. So that is the only difference. That's the only thing we need to do. We don't have to make any code changes to the actual code. And if I run it without InstantOn, we'll see that the application starts up. They'll tell us here in a second. The application took 8.25 seconds, and I think I'm running it right here. This is a UI associated with it. Okay, let's kill that. And now we'll run with InstantOn. So that was 8.5 seconds. And now it starts in 500 milliseconds. I also moved this to Kubernetes, Knative. So Knative is the extension, which is for serverless. So I'm going to, the way that works is that you load an image and when it's not being used, it shuts down. So you're not being charged for it. So if you look to see, if I take a look at the pods, there's no pods running for this. I have started them previously. So if we hit those endpoints, it'll start those up. So here's the one without InstantOn. Let me close this so that you'll get a better indication that it's come back. Well, I'll go ahead and start this, and I'll time it. Let's see. So 1, 2, 3, 4, a little over 4 seconds. And now I'll do it with the InstantOn version. 1, 2, about 2 seconds. Now, you're probably wondering, why isn't it starting in 8 seconds or 3 seconds or 500 milliseconds? Well, the problem is the cold start time of the actual framework that's starting. This is serverless. So in this case, it's Knative. It's usually a 2 to 3 second delay to restart that thing. So no matter how fast you make your application, so it's good to go from 8 seconds to 500 milliseconds, but realize that cold start is also another issue. And I assume that's going to get better too with time. Oh, I wanted to show those pods. So you'll see that both pods are running. And after about 60 seconds of no access, they should terminate themselves. Yeah, the first one's already starting to terminate. So that's that. All right, we'll go back to our presentation. Okay. So the last thing we're going to talk about is Oracle GraalVM native image. So this is the most extreme method for running your Java apps. So I say it's extreme because it basically eliminates the need for the JVM by compiling your code ahead of time. So just like any other compiled language like C. So this will definitely avoid any startup or ramp-up time delays, but there are some drawbacks. So first off, compiling ahead of time means everything needs to be known. So this is referred to as the closed world assumption. So no more dynamic code like Java reflection. So this technology is provided by Oracle GraalVM, which is again open source. So it actually has two modes. So one is an extended JIT to optimize JVM performance, and the other is to compile into native image executables. And we'll only be looking at the second part there, the second piece. So by being less dynamic, GraalVM native language is geared specifically for short-lived workloads. So remember, there's no JVM and JIT anymore, and ahead-of-time compiles will never be as optimized as a JIT compiler. Also, garbage collection is not as efficient, which may be a problem the longer you run. But the executable has a very small footprint, so it has a lot of positives. It has very fast startup. So again, it's supported in these currently with some frameworks like Spring Boot, Micronaut again, Helidon, and Quarkus. And for this one, to learn more about this, I went to the Quarkus website. They have some good documentation and some starter apps. So Quarkus is a Kubernetes native Java framework tailored specifically for GraalVM and Hotspot JVM. And as you can see here, it's open source and has a great developer community. So no time for demo, but I'll give you the results. First of all, the startup time is incredible. The fastest yet, but it did take 5.5 minutes, 5 minutes, 13 seconds to compile. So this is one of the drawbacks we're talking about. From a developer, this may not be what you're looking for. And that's the kind of things that YK is going to talk about next.
Yeah, thanks, Rich. So in the last, I guess, 15, 20 minutes, you we've seen, we talked through the three different approaches to fast startup that we have tried to share with you all here, right? CRaC, InstantOn, and native image. And let's take a moment to see what they offer, right? So summary view of things, right? So when it comes to startup and ramp up, pretty much all three of them offer us the answers to that, right? So very quickly, when it comes to bringing up your workloads, when you need to do it, deploy things in a serverless environment or even as functions, right? So you have that across the board. And fast ramp up is pretty much there to trying to get to just running your workloads, right? And yeah, they all help you to reduce what you need when it comes to CPU utilization, right? So but the same when it comes to footprint, there's a difference, right? CRaC and InstantOn, it's not about reducing what you have today, right? Basically, your install footprint or on disk footprint remains the same, but with native image, because it's compiled to native, right? So obviously, when it comes to what you have and run at the end, it's indeed much smaller, right? So the benefits there go to native image. Then when we look at what the developer, or when it comes to developer and then the developer experience, right, or what the developer has to do within a development environment, there are differences, right? So with CRaC, depending on the framework or what you'll use, then you may have to do more or less. You may have to change what you need to work with, right, and so on. So that's a maybe when it comes to developer experience, depending on what you are working with, right? For Liberty InstantOn, as we mentioned, it's a full stack solution. It's designed to minimize what developer need to worry about, or what developers need to worry about, so that you can pretty much do the way you do development the same, and yet you can just easily create a snapshot or a checkpoint and then restore that and get the full benefits of very fast start and so on and so forth, right? As Rich mentioned, with native image, right, it's a completely different approach from a build and deploy standpoint. Well, not so much deploy, but certainly from build, because you need to build to compile to native and build that and work with that when it comes to deployment, right? So the benefits here go to InstantOn. And when it comes to things like full Java API support, we know that native image doesn't have, you can't do some of the more dynamic operations or use some of the things like the fractions and so on. So that's a no there. And when it comes to class loading, and that's similar, right? The minus, in a sense, is with native image, although there may be workarounds to consider. Now, when it comes to code changes, as mentioned, right, the plus here in our experience goes to InstantOn, because it's designed meant to make life easier when it comes to adopting fast startup solutions for the developer, right? So there's no code changes pretty much required if everything works fine for your applications, if you don't have to worry about things here, right? So continuous security, by today, it's pretty much across the board. You have that, right? Previously, we hit some issues with CRaC, but I think given the latest that we found out and what we've learned, it's there across the board. We know, and then we look at the JVM and what JVM provides, including JIT, right? So when it comes to optimized GC, it's not as great. When it comes to native image, there is GC support, but obviously that's not a full-scale GC solution, and the same for JIT optimizations when you really need to drive towards throughput, right? So there is a bit of a consideration there you need to keep in mind when you go for a native image solution. And lastly, goes back to dev priority as one of the, I guess, key considerations when it comes to the 12-factor app or doing cloud native, right? So with CRaC and InstantOn, yes, there's dev priority, right? But certainly that's not the case with native image, right? But that's by design in a sense, but you have to keep that in mind when you weigh the options and see what will be good for your use cases and what you need to accomplish, right? So this is our view of what we've learned. So if you have thoughts or feedback, let us know, and then we're happy. If we missed something, let us know, then we'll take them into considerations and add to our potentially future versions of this discussion, right? So yeah, all three offer excellent solutions to the problem of slow startup, right? And really evolve the Java space for cloud native, right? At the same time, they have pros and cons, so you need to weigh that, right? As Bruno said when we were welcomed on stage, right? So keep that in mind and weigh what you need for your business and your adoption, and then see which one works best for you, right? And there's also other cloud native Java solutions that we won't get to discuss today given time, right? There is what we call JIT as a service, right? Or you answer where the JIT is no longer needing to reside with your JVM, but can run separately or outside of a JVM, and that brings you further value in terms of saving, and when it comes to disk footprint, and if footprint is of concern, right, at the same time gives you the benefit of having just-in-time compilation to optimize what you need to run, right? So those would be, that's another topic, I guess, for another day, but these would be solutions when it comes to really making Java good and fast and performing for cloud-native deployments, right? So yeah, that's all that we have for today, because we're excited and we are privileged, and thank you for having us here. And hopefully you find this short talk in, I think, just about 25 minutes good for everyone. And you have any thoughts, let us know. Thank you.
All right, guys, thank you so much for this. This was a great presentation, and yeah, I'm curious to give this InstantOn a try one day. One question I have for you: how do you see? There's another way to take advantage of CPU time in Kubernetes for JVM workloads, where you can configure a deployment without CPU limits for a few seconds in the beginning.
Oh.
So there's this configuration in Kubernetes now that it's called CPU boost. And it literally, you give like, okay, 30 seconds, 60 seconds, whatever. So in the beginning, when the pod is instantiating, the process inside has access to as much CPU as it can get. And then after that amount of time, then the CPU limit gets applied, and then the traditional whatever the application does will have to meet that CPU limit.
Yeah, I think that can help. I think that helps with container size initially, because that's hard to do when you have to weigh in all those the JIT compiles. So that may be a solution to that, but you're still going to start slow.
That's
right. So that we're trying to get instant startup and instant shutdown. So
right, yeah. I think we are trying to get that time to peak performance, right?
Yeah.
The warm up
faster. It will be faster, but the whole point behind the checkpoint restore is that we've done that ahead of time and it's saved in the image. So when it starts up, it's ready to go.
Yeah. And by the way, we have I think we have Loyan on stage. Loyan, can you join us?
Hey everybody.
Right.
Hello.
Hey, how are you?
Good, you?
Yeah, we are all good here. We're talking about startup time, warm-up time, peak performance, Git as a service, checkpoint restore, GraalVM native image, CRaC, and so on. So, Loyan, have you tried any of these things to make your applications faster?
I have tried the GraalVM, but only for POCs, nothing ready in production yet.
So
but I would love to have something in production.
So you went to native image.
Yep.
Did you find that you had to pull out some code, or all the code was transportable, or do you run any issues?
Since it was mainly POCs,
Oh.
so it was very simple code, so I didn't have to touch anything.
Okay.
I was very lucky.
Hello world, yes. Okay.
Yeah.
So, Loyan, one of the challenges that I have experienced with things like native images testing, once you have a native image, you also have to test the native image, because ultimately it's a different thing than the JVM mode of the Java application. And to the speakers here, I think if you have a snapshot from CRaC restored, you also have kind of different thing than you did from testing, or is it really the same thing?
You were two different directions. So the native image does require different debugging tools, right? You have a different executable. And then for CRaC and InstantOn, it's still your normal JVM, and so those tools should work. As far as testing and then hoping for the same thing in the image, I think they would be similar. I think YK has probably more insight than I do on that.
Right, it's similar. So essentially, when you test at steady state, that should be what you'll be getting, right? So that's the idea behind it, right? So.
All right. So, Loyan, you're gonna talk about using AI to test stuff.
Yes.
How can Chunk and Rich use AI to test Java performance?
That will be good to know and learn. Looking forward to that. Yeah.
That would be amazing. I saw this last week. I played with doing an MCP server that can run all the JDK tools, JPS, JCommand, trigger a JFR, trigger a GC log, etc. And it was fascinating to see how it could just, give me a heap dump. And then that's my command, give me a heap dump. And then the MCP server went and triggered a heap dump for the JVM that I was interested in. Now, enable GC log. And, has any of you configured GC log? It's a great experience of finding out the right commanders for the command line. So I went in there, so enable GC log for this JVM is already up and running. And the LLM got it right and enabled using JCommand to get the GC log while the JVM is up and running. So I'm like, wow, I don't need to be a JVM expert anymore. But and even people should be, but the LLM was able to get a dump of the memory, the garbage collection stats, and give a summary of the state of the garbage collector, like pressure, allocation rate, things like that, and even provide some sort of recommendation to enhance of the application. So I think eventually AI will get there in implementing a troubleshooter in production, and maybe hopefully reduce the amount of tests that we have to do. But I don't think Leanne is here for that. So Leanne, all right, Rich, Chang, thank you so much for your time. Thank you for your talk.
Thank you.
All right. Thank you very much.
Right, Leanne. So AI-driven test development. Enlighten us how and why this is the sort of thing that developers should care about now. So the stage is yours. Thank you.
Thank you. Okay. Hi, everybody. Great to be here today. So we're going to talk about tests modern or harder and how AI tools such as GitHub Copilot can help us to be a little bit more productive. I think it's still a little bit weird that in 2025, we still have to talk about how testing our code is important. Believe me, there are still developers out there that are delivering code without any kind of unit testing. But I'm also happy to know that there are some companies and some big players out there that are making this part of their pipeline and not allowing any code to be moved to production without actually to be tested. And this is even for legacy code as well. So, and whenever we are also coding, whenever we get a task to deliver some business functionality and a business feature, and we have to code it, what usually happens is that you deliver that functionality, you have all your code, and then when you have to write all the unit testing, you end up running more code for testing what you have created than the business logic itself. And I think this is where AI tools shine to help us. I usually like to joke that I'm a lazy developer, and that's why I love AI so much, especially Copilot, because I can focus only on building that business logic to deliver the value that I have to deliver to the code that I'm pushing to production. And I can rely on tools to help me to write code faster and still deliver my tasks on time. So this is exactly what I would like to show you today. So my name is Loyani, or Loyan. I'm a director of engineering at Bank of New York. I'm also a Java champion and MVP. And in case you'd like to contact me, I'll leave my LinkedIn profile as well, so we can exchange some ideas on testing and AI and, of course, Java. So let's get directly to the code. This is going to be a complete live coding session, and let's get to it. So give me 1 second and I will switch my screen. Hopefully you can see VS Code. I'm going to use VS Code here. I got very familiar in using VS Code for Java. It has become one of my favorite editors and IDE as well. But I do love IntelliJ, don't get me wrong. But especially when working with Copilot, I do prefer to use VS Code, even if it's a Java project. Quickly, I have created a REST API, a very simple REST API, and I'm just going to show you very, very quickly. So we have an entity, which is a document where we have a few columns here. We have a few properties here for this product. We also have, of course, the repository, so we can connect to the database. We also have one method here just to find by name. We also have a service class. We're kind of use the MVC pattern here, where all the business logic is in the service class. We do have a mapper because we are using some DTOs and to, of course, encapsulate our entity and not expose our entity. And to quickly take a look at the DTO, it's a pretty simple record. I love using records for this kind of pattern. And we also have a mapper because I only have one entity here. I'm not using any external library, but never hurt to code 30 seconds for your own mapper. So we have find my ID, we have a create, we also have Jakarta being validations, Hibernate validations here as well, just to make sure that we are validating input. Update, there are some logic here. We cannot create duplicated products. We cannot try to update a product with a name of another product, hence duplicating it. And very simple code, like 70 lines of code for the entire business logic that we have over here. And of course, the controller is pretty lean and simple. We're only exposing the service and then exposing all the endpoints and the DTO as well, so we can call the service. Very, very simple. And we also have some controller advice just so we can handle exceptions. Right now, if we take a look, so if I click on this lab icon, I have 0 tests configured. This is a Spring project. And I also have some test containers because why not just give a little bit of twist and enhance as well and go beyond the unit testing and add some integration tests here. So I have some test containers here as well. And if you go to my pom.xml file, you will see that we have the test containers and also the MongoDB container dependency. So pretty simple project. We have 0% of test coverage right now. So what I would like to do here today with you is let's see how much we can do within the next 10-15 minutes and see where we are. And this is exactly the message that I would like you to take today. Within 10-15 minutes, a very simple REST API, we'll see how many lines of code we are able to do. And we will not write too much code here. We're going to rely on AI to do all that for us. So 2 approaches that I would like to show you today. The first one, I'm going to rely completely on GitHub Copilot chat. So to do that, let me open Copilot chat over here. And there are a few things that we can do, right? A few approaches. I'll show you what usually works the best for me and what I have done it before. You can, of course, there are a few different options, but there are a few tricks here in Copilot so we can leverage and get the most out of it. So if I open the product service, I'll go directly to the service. This is because where we have all the business logic, right? So let's start with the service itself. And I'm going to ask Copilot, if you take a look, we have a current file. So right here in the bottom of the page in the chat, we have the current file. This is going to be used as a context by GitHub Copilot. So I can simply ask Copilot, generate test cases for the product service class. And of course, you can select which LLM that you like to use. I've been enjoying to use the O3 Mini, especially for this kind of test. And we just have to wait a little bit. It's going to run. There's some pseudocode because, of course, it's very important to understand what we're doing, what kind of code we are accepting into our project. And just always remember that even though this is code that has been generated by AI, as soon as you commit, this code becomes your code. It's your name in the commit message, in the commit signature that is there. So it's very important to understand exactly what you are accepting. Let's take a look at this code. So it's importing JUnit 5, Mockito, fine. I like that. Extend with Mockito. I also kind of like that. It's creating mocks for the repository and the mapper. Okay, and then instantiating and writing the method for the test method for each of the methods that I have in my class. I already see one issue over here, and you never know what you're going to get, right? So the package is right here in the middle after the imports, and then you have a dummy product class for testing purposes. We already have that in our code, so there is no need to recreate this. And then we have this product service test we are mocking. That's fine. We have a before each. It's also fine. And it's creating some test methods. And it generated 125 lines of code and generated for the create. So basically, it's only testing 2 methods. I really don't like this. And the reason, and it's completely fine, because what the AI tool is going to try to do behind the scenes, all it had as a context was this file. So if we take a look at this file, we have a product DTO, we have a product mapper. We only have the signature of each of these the methods, right? And we also have a few things such as the name. We have, especially here on the update, we can see that we have a name, description, category, and price as well. So it's able to extract some information, but it doesn't have all the context to actually generate something for us. We could try to improve this. So even if you have this code, for example, the package needs to go on the first line. So I can tell the AI tool to do that. But I would like to show you something else, actually a better way to do that. So that's why I think it's important for us to try to master and learn this tool so we can take the best advantage out of it. Let me close everything. So I'm not going to save this. I'm not going to accept this. So instead, what I'm going to do, if we check here, we have this at. So if we click here, we have all these different options, right? So we can sort of pass some arguments. We can also set up tests. It's going to be very similar. Again, I can select the service, and it can be simple as I have product service selected over here, or you could simply drag and drop as well. It will take that into consideration. I don't have to write anything. All I have to do is press enter. And again, the tool is going to use one reference and will try to generate the code for us. Again, it's going to give us a few options here. I didn't give us much in this particular case. So I really don't like this at all. Let me show you something else instead. Let me click on a new so we can start from scratch. And what I'm going to do, I can leave this file open. That's fine. Don't have to close it. But if we come here again and I select the workspace, this is the trick for me, especially when creating tests, so I don't have to coach Copilot too much. So what I'm going to do is generate unit tests for the product service class. I'll press enter. Now, look at the difference here. It is using 21 references instead of that one particular file. So now I'm going to be expecting a much better result out of it. It's going to collect all the workspace information, and it's going to provide a much better context so we can actually get better results. So we just have to wait a little bit here until we're able to get that result back. And hope everybody is doing well as we wait for Copilot to generate things for us. And take this into consideration, because we are providing all this context to the AI. The bigger your project with more files, more code, it can take a little bit longer to generate that source code for you. So if you have the big project with hundreds of files, that's definitely going to take a while, because it will take all that source code into consideration. So let's see. And it's collecting all the source code information, and it's definitely getting the information for us. So this is the first approach. As soon as we get the results from here, we're going to try to apply, and we're going to try to run this code to see how much code coverage we can get it. And although I've been talking for a while, we haven't written any lines of code yet. So this is basically only reliant on the AI tool. So let's see what we get in return. In case if you have any questions, please feel free to leave them on the chat, and I can take a look at them as well as we get our results. And we already have some. This is pretty exciting. I see the package on the first line, so I'm already very happy with it. And I can see that we got a lot of code out of it. Look at this. This is beautiful. This is beautiful, beautiful. So we have a product service test, and yeah, I very much like this. Let's see what we get that. So let me create a new file here real quick, and let me apply this to this file. Actually, see, Copilot's even better in VS Code. It's already creating the file for me. I didn't have to create a new file manually, which is perfect. Great. So let me close this, and let's see what we got. I have a mock. Perfect. It's injecting the mocks. I have a valid ID. It has created some sort of like constants here. We can do better. We can make this static as well. We can just put everything into all caps, just so we follow some conventions. It has created some sample product for me during the setup. And I have a testifying ID. I have an ID not found. So we are testing the happy path. We're also testing the not happy path. A create with success, create with duplicate. So those special cases that I have in my source code, it's also here. The update success, different ID, not found. This is 155 lines of code. I didn't have to write anything, just had to, ask Copilot. So now if I go here and I try to execute, I'm going to ask to run with the test coverage just to see what we're going to get. And again, we're still not using test container. This is only some sort of like a unit testing that we have written. So it's going to take a few more seconds, and it's going to run the code for us, and hopefully all the test cases will pass. And if we can see here, we have a good amount of test cases already, 10 test cases. And I love seeing everything green. So look at that. I did not write a single line of code, and I already have 58%. We can do better. Let's aim for maybe 70, 80%. So this is definitely one way to do it. Now what I would like to walk you through is, let's use the auto-completion option that we have here in Copilot. So I'm not going to use Copilot Chat. I'm also going to rely on the auto-completion from Copilot here, so I can actually coach Copilot on the way that I would like to get my tests written. So this way, I'm going to do one method by method. And once I get the first method exactly the way I want, we'll see that Copilot will try to generate the next method a little bit more closer to our coding style. And again, I find this to be beautiful. So let's do that. Whenever we're using Copilot in this particular approach, we have to provide as much context as we can. So what I'm going to do, since I have 0 test coverage from the controller, I'm going to get one controller. Maybe let's test the find by ID. right? So what I'm going to do, and usually this is one of the things that I like to add. So the method under test is going to be, and I'm going to add here a link. It's going to be my product controller. Almost there. Controller, find by ID string. Perfect. And now let's see, we get a test, of course. The other thing that I would like to also to coach Copilot is what exactly I would like to test. So to do that, I like to use the display name, and also because it looks really cool in the text explorer. So this is going to be should return a product when exists. There you go. Let's see. This is enough context. Test find by ID, because I already provided a context over here. And I think I need to import this again. Let's see. It's the Jupyter API. And I have a product, and probably I need to import the DTO as well. Yes, I need to import the DTO. Get for object, it's fine. I'm fine. We could do better than this, but for now, it's okay. I also have a product. So one of the things that I'm going to do here, I'm going to create a static method that returns a product. Let's see if Copilot's going to be able to give me something. Create product. Nice, but I don't want this. I want to create something like this. So I'm just going to copy here really quick, sort of like a data factory of some sort. And what I'll do here, and what's the name of my method? Create product. So create product. There we go. Okay, I like this. We need to also set an ID. And there we go. So these assertions here, I don't like it very much. So let's see. I'm just going to remove and see what Copilot is going to come back with me. So first, assert not null. And I'll get a response. Yes, this is it. And then maybe we get assert equals. Let's see the response, and then I'll get the ID with the product ID. Get ID. Perfect. This is pending now because this is a record. Okay, now Copilot gets it, and it's giving me everything else. Okay, this is good. Let's see if this is actually passing. So we're going to run. This is the test containers, and it's actually going to rely on MongoDB integration tests, and it's going to test our code end to end. We're not mocking anything, which is the beauty of test containers. And there we go. It's running. And as it's running, we'll also check, because it's test containers, it's going to take a little while because it's going to use our Docker Compose. It's going to try to bring up the containers, run the tests, and then remove the containers as well. So still running. But what I would like to show you after this runs is the next time that we are trying now, I can try the create. I'm going to do the test. See that now the whatever Copilot's trying to guess what I'm trying to write next, it's actually getting my style of coding. Now it's no longer creating that product manually. It's actually relying on the create product. And again, we have all the other things that we were, the post for object, the assert equals, everything else. So I think this is pretty nice. Another method, and already has my code style. Let me try to run this again. This time I'm going to try to run everything since we only have a few minutes left. And we're going to see how much test coverage that we got out of it. Again, here you're going to try to coach Copilot, but you're going to get something that is a little bit closer to what you were written if you're just doing this from scratch. So we have created basically 90 lines of code. And here again, we have 156, so 240. Let's round it up, 250 lines of code. And we did that in what, 15 minutes. Just doing that, we have 13 test cases now that have been added to our project, which is a pretty good number considering this is a very small API. And now all we have to do is to confirm how much test coverage that we gotten with only a 15 minutes with minor effort from our side. This is something that I really enjoy, and this is when I get the most out of the AI tools. I really love using Copilot and coding assistants, especially to write unit tests for me, because I think this is where it adds more value and allows me to spend more time actually writing the business logic instead of spending my time writing a lot of the test cases that I need to write. So just a few more seconds so we can do that double check of how much test coverage we've gotten out of this exercise. And if you have any questions in the chat, let me know as well. We're almost done here. Just waiting on that test coverage scripts. And it seems now it's running. Let's see if everybody is passing. I want to see that green check. Just again, wrapping up everything. And look at that. 86% of test coverage in our project. We only would have to test the exceptions, but this is a pretty good number, and now we can pass all the quality gates as well. So again, I hope you have seen what you can do. In case if you have any questions or if you like to chat a little bit more, please connect with me on LinkedIn and I'll be happy to do that. Thank you very much.
All right, Lorian, thank you so much for the presentation. Thank you again for supporting the Java community in this Microsoft JDConf event. I hope to see you and all the other speakers in person one day, bringing JDConf to life. For now, we are still trying to leverage the location of all these speakers and all the community, because as you saw in the agenda, we have this time zone. We also have events covering Europe and Middle East and Africa and Asia Pacific. And it's such a great way to get everyone participating. Just so I understand, you are right now in Miami, correct? Or Florida?
I'm in Orlando.
Orlando. Okay. All right. Awesome. So that's another time zone, like 3-4 hours ahead of me already. And it's such a great way for people to connect. Again, thank you so much for your presentation. Thank you so much for being part of JDConf this year. It's not your first time, and I hope it's not the last. We're going to keep running JDConf in the future. Is there any particular session here that you would like to highlight from the Asia Pacific and EMEA time zones that you feel like I'm curious about this one?
I think anything related to AI, I'll be very interested in. I see that we have another session on GitHub Copilot for Java as well. But modernization, I think this is going to be a pretty nice one. The modernized Java applications using GitHub Copilot upgrade assistance for Java. Because especially right now, there are so many legacy codes out there. I think that's the beauty of Java, right? Java has been up and running for 30 years. So we have applications that have been in production for 30 years. And how we can speed up and bring that code base from a legacy code base to use all the modern functionalities that we have available in Java. So I'm pretty interested to watch that one.
Nice. Me too, by the way. I've seen this capability on Visual Studio Code with GitHub Copilot. It's such a great tool that can help us modernize with ease, right, as we go. But we gotta have those tests ready, right? You see, if you're gonna touch the code, make sure we have tests to verify that those changes are still working. Okay, so there is one other reminder here for Microsoft Rewards. Yeah, again, thank you, Loyan, for your participation. For folks joining, and if you missed Americas, remember, register for JDConf. Be one of the first 300 attendees to check in on the Microsoft Reactor event page, and you'll get extra points. What can you do with those points? Gift cards, digital goods, anything that you can see in the Microsoft Rewards website. Now, we have lots of speakers still to go, and for the next time zones, keep an eye on Sandra Algrim, keep an eye on Rory Preddy, because they will be your hosts for those events. They will welcome you in those time zones, and they will do an amazing job, even better than I did for this time zone. So with that, thank you so much for being part of the first edition of the first day of JDConf 2025, and I hope to see you soon on the next time zones. Enjoy the rest of your day or evening, and see you soon.